Good morning, everybody. Nice to see that the whiskey off is over now. I hope you all had some sleep. I did, but not too much. Welcome to the working group, RPKI working group this morning. We have 4 different presentations, and oh, there's a slide thing I have to press. We first, however, do something about the microphone etiquette. If you come to the microphone and have something to say, please state your name, your affiliation, and please remember we have a code of conduct as well. The approval of the RIPE 89 minutes, they've been on the website for I don't know how long enough. Thank you to RIPE NCC for making them. We haven't seen any comments, which is usual. I don't know if everybody actually reads them, but it's your choice. So if anyone has anything to say about that yet? No? There's bright lights here and there's something in the back of my head that's sticking me. But anyway, then they're approved. Thank you for that. Then Maynard Koch, please come to the stage and tell us about amplification through IPv6 routing loops and a call to fix router configurations.
Okay. Good morning, everyone. Sorry. Yeah, welcome to my talk about amplification through routing loops in IPv6. This is the extended version of my lightning talk, which I already presented on Tuesday. Yeah. So the next few slides, if you already listened to that, the next few slides might look familiar to you. But I do have some more slides and insights I want to share. So let's start. Imagine you send a ping request, a single one, to an arbitrary IPv6 destination address. Oh, sorry, the timer's not working. I mean, I don't mind if I have infinite time, but okay. So what would you expect? You would expect to receive at most 1 reply for your single ping request. But now imagine if you, instead of receiving 1 reply, you receive thousands, hundreds of thousands of ICMP TTL exceeded messages. And that's exactly what we observed. A single ICMP echo request triggers more than 250,000 replies from the same router. And don't worry, we also know how to increase this even further. Why is that? So this is the interplay, a combination of 2 issues, which are known and also discussed since a few years. The first one are routing loops, which lead to unnecessary traffic between the looping routers. And the second one is a software bug about TTL exceeded amplification. So packets that loop get duplicated, causing even more network load between the routers and also causing a huge load at the client that sends the request. So what exactly is a routing loop? Imagine you have 2 routers, we say R1 and R2, and the first one, R1, is the provider and assigns a less specific covering prefix, let's say a /32 to its customers, to its customer R2. But R2, however, only uses a tiny fraction of the address space. So it only configures paths for more specific /48s, let's say for Bobo and for Dodo. And for all other remaining paths, it just has its default route. So each packet that does not fit into the paths that are configured are just routed back to R1 via the default route. And that's exactly where the routing loop emerges. So imagine you want to check if your cafe number 1 is open. So you send a ping request. What happens is that R2 does not know where cafe number 1 is. So it just uses the default route to R1, but R1 has a less specific cupping route assigned to R2, so the packet starts looping. And yeah, that's actually pretty common in IPv6 because you have these provider aggregatable address space, and you get large chunks of address space, and if your customers don't care that much, or maybe not, they do not know how to properly configure the routes, that's where the routing loops might emerge. So in the end, you get the ICMP-TTL exceeded message that gets triggered when the packet, the time to live of the packet reaches 0. So an ICMP-TTL exceeded message is sent back to the original source of the request. But in our case, it's not a single not a single reply, but 250,000 or even more. And that's because of a router bug that duplicates the incoming ICMP echo request. So it sends back 2 ICMP echo requests. And in the next loop iteration, these 2 arrive at the router, and they're doubled because each individual echo request is duplicated. So that's an exponential increase. And on the one side, the exponential increase is between the routers, so you start to create huge loads of traffic between these routers. But finally, each individual echo request triggers an individual ICMP-TTL exceeded reply message. So these are all sent back to the original source, which is also a nice target for attackers to just flood the victim with ICMP-TTL exceeded messages. How can you prevent that? It's actually pretty easy. There are more ways to prevent that, but one of the simpler ways would be to just set a null route, to require your customers to have null routes configured for the address space they assign to their customers. And if all the other traffic gets black-holed for the assigned address space, no routing loop can emerge. To better understand the deployments, we conducted some measurements in the wilds, and we found 141 million routing loops or looping subnets, which means you send a request to one of the 48 subnets within the to one of the 48 subnets, and you trigger a routing loop. So that increased by 15% in the second measurement, up to 162 million. Here you see on the y-axis the number of looping /48 subnets, and on the x-axis we just rank the AS numbers that have routing loops. So in total we find more than 5,000 ASs are affected by these routing loops, distributed over 155 countries, and 18% of all looping subnets, they concentrate in only 5 ASs, so there is a dense spot, and 55% of all looping subnets concentrate in also only 5 countries. So how many of these looping subnets do also amplify the responses? We found that 7.4 million of the /48 subnets do also amplify in November 2024, and this also increased to 10 million in April 2025. So this plot is pretty similar, but instead of the looping subnets, it now shows the amplifying subnets. We do find about 1,900 ASs to be affected, distributed over 100 countries. 9% of all amplifying subnets, they concentrate in 10 ASs. And interestingly, 82% of all amplifying subnets concentrate in only 5 countries, with Brazil alone accounting for 72%. So what about the amplification factors? So you might notice most of the amplification factors are rather low. So 99% are below 6. But for the 1%, they go up to like 10,000, 50,000, 250,000. And we found out that 8 routers are especially affected from that. And they do reach these amplification factors of more than 250,000. And they're operated by a single German ISP. So we contacted them and found out, okay, these are Juniper layer 3 switches of the EX production line. That's not good, but it's very bad that it won't get fixed that easy. So what did we else try to do? We tried to inform all of the affected network operators. And we started an email campaign, and it kind of backfired. So first of all, sorry for all that noise we created. But to motivate the operators to reply to our mail campaign, what we did was we kept the initial mail intentionally vague without any specific details of affected devices. So in the end, we received more than 1,000, actually, I think it was about 1,500 replies, including phone calls in my office. Very nice. So if you put your affiliation in the signature, people will actually try to find you and check if it's legit. I mean, that's good. But to be honest, we definitely didn't expect that. So while the majority also appreciated our work, and so did we, your reply, thank you very much, we also received a lot of complaints about spreading panic by not sharing specific information at first hand. So learning here is, or a promise for the future, we will include all important details in the first mail, of course. But please reply. Even if the email helped already fixing the issue, we rely on your help. So the impact of the mail campaign, it actually worked out. So we got fewer loops. We reduced the number of routing loops by about 7.7 billion. And 134 ASs just have no more routing loops. So very nice. We also see less amplification for the number of amplifying subnets. So in that case, it's about 54 ASs that reduce the number of looping subnets by just setting null routes. And of these, 32 just removed completely from the threat landscape. So great. Overflowing inbox, but still some impact. But there's still a lot to do. I mean, you saw that the number of routing loops increased. So yeah, we need to work together and fix the issue. In particular, given that this is already a known issue. So in conclusion, loops are bad, amplification is worse. And IPv6 deployments make routing loops far more likely than in IPv4. And some of the IPv6 router implementations, they do duplicate ICMP echo requests, creating huge loads of traffic at potential targets of such a flooding attack. And we can expect an increasing threat potential because of increasing IPv6 deployment. Oh. Hello? Okay. So if you operate an IPv6 network and you use the default route, please also install null routes. And that's also, we kindly ask providers to tell their customers to teach them how to properly set these null routes. And if you do IPv6 scanning, like we do, we always want to keep the impact on the load in the networks low. So try to exclude the network's routing loops. We can provide data for that, if that helps. And please do not use unnecessarily high IPTTL values, because the higher the IPTTL value, the more amplification you get. So a value of 64 should be sufficient in most cases. That's all I have for you today. Thanks for listening. I'm happy to answer any questions.
Thank you, Maynard. So, are there any questions?
Hello, Jan Linkova. Thank you very much. Very interesting. I'm thinking about routing loops. I suspect, I'm wondering if you looked into it, I suspect the part of it might be broken CPs which do not install no route for delegated prefixes. Right? CP is supposed to do this, but I would not be surprised if they're not, especially when you see so much of the country-specific things. So maybe they're using specific vendor popular in the country. I'm wondering if you looked at interface IDs of responding routers to see if you see any like pattern in UI64 based interface IDs and see if it's actually, because that's why you see it more in V6 than in V4, because in V4 we don't use prefix delegation, right?
Yeah.
So I'm wondering if you looked into that.
I mean, we did not look into that, but that's a good point for future measurements. So I will keep that in mind. Thank you very much.
So then we have a question online from Alexander Zubkov. Have you tried to, sorry?
Okay. I'm sorry, Brian Candler, NSRC. So I'd just like to understand a little bit more about exactly what circumstance causes the packets to be duplicated. Is this only ICMP echo requests that are affected? And does it happen at the point when the TTL decrements from 1 to 0 or at some other time?
The duplication does not happen when the TTL reaches 0. The duplication already happens. It does not happen at the beginning. We are not sure when it happens. Maybe some queues or anything else is overflowing or full, and then there's duplication process. So if you send these packets, you see that for the first time you only receive like these ICMP TTL messages, and then they start somehow after, let's say, X iterations, they start to get duplicated. And we don't know exactly the underlying issue. It seems like, so we got in contact with the ISP that contacted Juniper, and they say they contacted their chip manufacturer, like they use Broadcom chips, and they say it looks like a hardware-related issue somehow, and so they won't fix it. Yeah.
And do you know if it's only ICMP, or if you sent a UDP packet and that was looping, would that be affected too?
Currently, we think it's only ICMP, but I did not have the time to verify that. It might be also work with UDP or TCP, so we need to check that.
Okay, thank you.
So nobody at the mic anymore. Good morning. Alexander Zubkov is asking, have you tried to identify the unique loops? I mean, when the loops occur along the same path, or at least try to aggregate it somehow, because it is obvious that multiple /48 loops could be caused by a single misconfig.
Yeah.
And he also wants to add another note that from my experience, because loops cause excessive traffic between the routers, so for a larger TTL, the number of times the packet jumps between the misconfigured router increases. So the probability of it being dropped. So when scanning with higher TTL, the probability to receive the reply drops. Also, some routers do not emit errors, and you cannot get a reply with TTL, but will get a reply with TTL +1.
Again, you get a TTL +1. What was the last part?
That was the last part.
Okay. Okay. First, yes, there are only, I think, like 60,000 route IPs affected. So, of course, these do have more than one /48 looping subnet. So if you can fix like all these routing IPs, router IPs, you will also remove more looping subnets. And for the other part, yes, I think that might be an issue, but we have not looked into more detail into that currently.
Then Andrei Caletka.
Yes, hello. I just like Ondřej Caletka, RPKI, speaking with my IPv6 trainer hat. What time unit is TTL measured? Is it seconds, minutes, years?
What do you mean? What time is TTL?
It's time to life, the TTL.
Yes, the IPTTL, yes.
Yeah. Well, basically, no. I'm just doing.
I mean, it's in IPv6. It's the hop limit, right?
Exactly. That was my point. Basically, the whole presentation is about IPv6, and you talk about TTL, which is a terminology from IPv4. It's hop limit because it makes much more sense calling it hop limit if there's no time included in this.
Yes. Thank you for pointing that out.
Okay, and we're going to close the lines because we have only less than a minute. I want to, Gert During is commenting that I want to point out that BCP 38 source addresses validation on the ISP side will stop routing loops between ISP and a customer just fine. So please deploy BCP 38.sav.
That's exactly right, what we also would like to have. So use network ingress filtering. You can also use reverse path filtering. These are all options that would stop these routing loops from emerge and don't require to interact with the customers. So yeah, there are some other options. Thanks for pointing that out.
Okay, thank you, Maynard.
Thank you very much.
We have to switch the order of presentations because we are still waiting for Fernando to join MeetEcho. So our next speaker is Ondřej Caletka, who is talking about challenges of running IPv6 only internal services.
Yeah, except that these unexpected changes are a little bit tricky for the tech support to get the right slides on the screen. So going once, going twice, and here they are. Okay, my name is Ondřej Caletka. I'm from RPKI, and except for sometimes being a little bit picky about terminology, I also really like IPv6. And I would like to tell you a story today. The story is about a failed attempt, so it's one of the stories that didn't end up well, but yeah, we still can, I hope, learn from it. So, first of all, can I get my clicker working? Yes, thank you. First of all, what are internal services? So, you can probably guess that something internal is something accessible only from internal, only for employees of the RPKI in this case. Historically, it was very easy, you know, back in the old days, there was an office, the office has computers. If somebody wanted to access internal services, they just have to be in the office and use the computers there. Then later, VPNs came, so you didn't have to be in the office, but you still use the VPN to access the network of the office where the services were deployed. Well, and then fast forward to now, where now internal services are even hosted somewhere in the cloud, on the internet, and basically using VPN doesn't make much sense more, but you still can have to log in with some good way of proving that you are really only internal RPKI employee to use them. How does it work in RPKI? We moved about 10 years ago to the new office at the central station of Amsterdam, and in that office, there is no more privileged network. Basically, if you go there and connect to the Wi-Fi, all you will get will be internet access. There is no special privilege that you get just by being in the office. Every device that every employee has a VPN client that is always on, and this VPN client is basically pushing some routes. It's split tunneling, so it's not redirecting your default gateway, but it's pushing you some routes to the privileged networks of RPKI so you can access the internal services. We use split tunneling on purpose because we have also office in Dubai and some remote workers, and being in Dubai, you would not be very happy to have everything tunneled to Amsterdam and back. Also, of course, the VPN supports IPv4 and IPv6 both for the tunnel itself, but also inside the tunnel. So it's very safe to assume that every single employee has IPv6 routes towards the private resources. And as I said, we are slowly, we are somehow also interacting with the cloud. And for that, we are actually having this ongoing migration from on-site LDAP-based login to something much more secure, which is single sign-on solution, because SSO assertion is much more secure than if you just type the same password to different services, especially if you use it with clouds. It's like that would be complete disaster to have LDAP login in the cloud. Also, one more thing, if service is running in the cloud, of course, it's completely useless to use IP-based authentication to figure out whether you are coming from a specific network, because, well, the service is somewhere in the cloud and there's public internet in front of it, and IP addresses are not encrypted or authenticated, so it doesn't make any sense. So seeing the situation, it's sort of logical that if we are going to build a new IPv, new internal service using IPv6 only makes very much more sense, because everybody has a VPN. The VPN is pushing the routes for the V6 resources, no matter whether your connectivity is IPv4 or IPv6, and every employee has it on their computer. So what could possibly go wrong? And here is where the story starts. This is the story of my colleague from the software engineering, because he joined the RIPE-NCC, and he remembers from his past that there was this t-shirt that I have on me right now. It's somewhere from 2010s. It's called IPv6 Act Now. And because he was eager to do things the right way, yeah, he just asked his coworkers, so we have this new service, everybody has this IPv6 route, what if we do it IPv6 only? And the response was, well, we never did it, but well, I guess so, we can do this, let's do it. Well, so he started figuring out how to do it, and he found some roadblocks in our configuration management system, which expected that everything is dual stack, or at least has working before. And also our monitoring system requested that every single machine has IPv4, but all these could be fixed and were fixed actually. So it was just like a minor issues. And then the first prototype was deployed, and he just sent a message to the users of that new service and asked them for feedback. And first coworker in the office said, yeah, it looks good, works well. Then another one working from home said, yes, it works well. And the third one says, it doesn't work at all. Why are you sending this? Basically, what the employee number 3 saw is like what you see on the screenshot on the right. Basically, the site cannot be reached, name not resolved. So quite a sequel to the previous, to the working group yesterday. It's always DNS. This is basically what happens, and you can probably already guess why the situation differed between employees. And this is what the employee number 3 actually saw. So basically, you can ping 6 that service, and you can see it will respond on pings, so it normally works. Then you try curl, and curl will tell you could not resolve host. Doesn't make sense, does it? Well, it doesn't make sense, but now we at least know why. It's because stub resolvers or operating systems are trying to be too smart. And at least Windows and macOS have this feature that the stub resolver tried to be smart whether it is worth to ask for query queries or not. So in macOS, you can see it by this output of this command scutil --DNS. Basically, if you are connected to IPv4 only network, it will have just flag on the left the request A records. Whereas if you are connected to a dual stack network, you will see flag request A record and request query record. And the problem is the fact that our VPN is pushing some specific routes, V6 routes to your operating system, does not convince the operating system resolver to start requesting query records. And this is basically the end of story. Basically, we cannot force our resolver to resolve quad-A records if the main connectivity of that computer is IPv4 only. Yeah, it is, at least in macOS and Windows, I haven't found any clear documentation what are the rules for filtering those queries or not filtering them. On macOS, you can see that there's inconsistent behavior depending on which kind of resolving API is used. That's the reason why ping 6 works, but curl or web browser does not. Yeah, this blue thing on the slide is a link to some gist on GitHub where somebody elaborated a very long article on how to do some undocumented SCUtil functions to make macOS resolve quad-A records, even if your v6 connectivity is only provided by a VPN. I tried that and it didn't work for our setup, I guess because of the split tunneling. So, well, that's sort of not so happy ending of this story. We had to roll back to dual stack. And so we have our dual stack service that is accessed over v6 for all the users that have a v6 at home. And it's accessed by v4 for the users that have only v4. Even though those users have also v6 reachability to it, their resolver will not send them to the v6 address. But at least we have now our tooling prepared for IPv6 only servers. So if we manage to fix or work around this issue somehow, we might be able to finally go with IPv6 only services at some point in time. And by the way, we also identified additional roadblocks that are not that obvious, but of course they are there as well, and something probably has to be done with them as well. So first of all, our single sign-on solution is called Okta. And this nice diagram from RipeStat, which visualizes how complicated DNS relation is between the domain name ripencc.okta.com and the IP addresses, is missing something important in this quad-A records. So just like the standard situation in the cloud and in the infrastructure as a service, basically they are IPv4 only. They haven't figured out yet that somebody would need IPv6. Actually, we asked, if you Google IPv6 Okta, you actually find a message of my colleague who asked whether they are going to do IPv6 and got the answer that we should submit it as an idea that other people from using Okta can share or vote on it. So we submitted that idea and it got 0 upvotes. Nobody using Okta is caring about v6 apparently. But what changed about 3 weeks ago is that Okta actually reached back to us and they told us, yeah, we were going to be first ones who's going to get IPv6 support. Not that because we care about you, but because we care about the US government. And according to US government, 50% of the government resources are supposed to be IPv6 only already. And we are scared that at one point in time, they will just try to replace Okta with something else because we don't do v6. So basically, this was finally some business case, and they decided that RipeNCC would probably be the good customer to pilot this on. So, well, we will watch this closely, and maybe I can tell you in a year or so that we have resolved this by asking them for implementing v6. They should pay us. What's the comment from the auditorium? I'm not sure about this. We pay for this. And it's not the only product that we have a dependency on. The second one is something that falls a little bit between RIPE 772, you know, this document that is defining the requirements for IPv6 equipment. It's CM system. Yeah, VR company, you already heard it from yesterday, for instance, that we are part of critical infrastructure. We are affected by many regulations that are requiring us to do security monitoring. And how we do it, we bought this software called Inside IDR from Rapid7. It has agent on each server that is collecting logs. So it's not in any way in the path of the packets. That's why it's not like a network device. But still, this agent that we install there, even though it only can talk IPv4 over to its backend. So of course, the servers would work even without it, but in order not to, well, we have sort of like policy that every server has to do it, so we have complete picture of the security incidents happening. So that's another thing. And if you, I again Googled inside IDR, and this was the only relevant link that I find. Somebody asked in March 2024, and there was complete silence. Of course, our security department also reached out to them, and they were, the story is more or less similar to Okta. So they, at one hand, don't really see an issue not supporting V6, but at the same time, they are aware that this US government thing might force them to do it. But, well, unfortunately, I cannot share that there is some development in this area further. So to wrap this up, I'm always wondering, is this just us? Like, not know things that I present here is unique to RIPE-NCC. I guess other companies also have VPNs. They probably also have V6 and VPNs. They probably also use Okta or something like that because, well, yeah, we are not the only ones. And it's 2025. We cannot even say that we are early adopters, are we? And according to this government mandate, it says that by the end of fiscal year 2024, which I guess already happened, it's like mid-2025, at least 50% of government IP-enabled assets should be IPv6 only. So I wonder how they selected those 50% to make it, you know, to make it still work if there are so many IPv4 only services. Anyway, we keep trying. We have our backend systems ready, and we are trying really hard to remove all the IPv4 dependencies. Though, of course, some products like this SSO or CM, they have like extremely small markets. So either you cannot find anything that would even support V6, or maybe you can trade the support for V6 for lack of other much more important features. Because in the end, yeah, even though I really care about V6, not the whole RIPE-NCC cares about IPv6, let's say it like this. Yeah, so some people just prefer more important features than IPv6 support. And that's everything from me. Thank you very much. And if you have any questions, I think we have still some time.
Yeah, thanks, Ondřej, for sharing your experiences. It's always useful. And we have questions in the room.
Yango, IPv6 enthusiast. Thank you very much. Very interesting. First of all, a side comment. So did you just said that some good could come out of US regulations? Oh, that's actually quite cool.
It's from the previous government.
Whatever. So actually, my actual question is, so if I understand correctly, part of the problem is that when you turn on, when your VPN is up, you do not override DNS configuration, right? So if your VPN config pushes V6 DNS to the client, your problem goes away, right? Or not? Not
really. Our VPN pushes a DNS route. It doesn't.
No, not DNS route.
Sorry, I mean like DNS server. You get DNS server over VPN. It has IPv6 addresses even, but still it's flagged like resolve. We don't, to be precise, we don't push like let's say the resolver of macOS is super complicated.
Yes.
And it is doing some sort of domain name routing. So basically, if you are connected to VPN, everything ending ripe.net, it's supposed to be resolved over the resolver that is behind the VPN over V6 and V4. The rest should keep being resolved by your normal resolver that you have.
Yeah, so it was exactly what I'm saying. So I guess if you completely override it and tells it you resolve everything to my VPN resolver, right, then your problem goes away.
Maybe. I haven't tried that. Could be the case. Because the question is, I'm not really sure what kind of rules are there for this requesting query records. Like, I'm only guessing that it's when you have default root, but I really don't know.
Yeah, because I'm just kind of speaking from experience. You can override it to, like, for example, my laptop always resolves through Google DNS, right? In V4 and V6, right? So even on V4 only network, I would have V6 addresses in the SC util, And that probably might be one of the approaches to fix that.
It's good to know. Thank you very much. And actually, I was also wanting to say something that I forgot. Yeah, I'm thinking of that maybe an IETF document that would be called like filtering quad-A records considered harmful would be helpful. And I'm trying to start with that one. And I know that I triggered Jen for.
No. I actually realized I forgot to ask you one thing. Could you please send a PR for V6 only operations considerations document talking about this? Because, yeah, we will forget.
Okay, good to know. Yes, thank you.
Hello, Kostas Zorbadelos, MTT. Thank you very much for this share of experience. And pretty much Jen covered me. I was wondering whether you tried with a different VPN software. Could it be perhaps that the VPN software does not interact correctly with the macOS underlying thing? And was it only on macOS that you saw this, or also on Linux and Windows, for example?
Okay, the second part, as far as I know, Linux does not do any quad-A filtering, so they just request quad-A all the time, so there shouldn't be issue. We use only macOS in RIPE-NCC, so we really don't care about Windows, but I am aware that Windows is doing some sort of filtering as well. Regarding VPN software, of course, this is quite tricky to just try because, again, our VPN software was chosen like 10 years ago, and it was exactly the case that basically we chose VPNs with the features that we want and IPv6 support, and we ended up with just one product that we could have. So that was like not really a choice. Basically, if we wanted to have some IPv6 support back then and also the corporate features of VPNs.
I understand.
So yeah, different VPNs are behaving differently. Some of them are implementing that fix that I mentioned on the slide with this SCUtil magic that somehow makes it resolve quad-A. But yeah, it's tricky.
Yeah. So the only question is, where do you actually complain? Do you complain to Apple or do you complain to the VPN provider?
I would say complain to Apple.
To Apple.
I think if I'm operating system and I have at least one route towards global unicast IP range, I should not be doing quad-A records because I never know what will be the result of the quad-A query. Maybe it will be inside the address range that I have route for, and therefore it's valuable. If I don't have any route towards IPv6 global unicast, then I think it's safe to assume that you can filter quad-A records.
Thank you again.
So we now have to close the microphone queues because we are already over time. Thank you, Andrei.
Thank you.
And now the next speaker is online. It's Fernando Gont, and he's talking about multiple routers, multiple interfaces, and multiple prefixes. Welcome, Fernando.
Hi there. Can you hear me?
Yes.
Okay, the only thing I don't see is the slide web. Perfect. And I guess I can control the slideware from here, or you have to, upgrade me. There you go. Perfect. So hello, everyone. My name is Fernando Gont, and this presentation is going to be about IPv6 support for multiple routers, multiple interfaces, and multiple prefixes. This is related to work that we are pursuing at the IETF. So let's start with a super brief introduction about what we refer to by multi-router, multi-interface, or multi-prefix, which throughout this presentation I will refer to as multi-IPv6, just as a shorthand. So essentially, what we call multi-IPv6 are scenarios where you have a combination of multiple routers, multiple interfaces, and/or multiple prefix. And these scenarios are like quite common. Some examples could be a laptop that connects to the internet via Ethernet and a Wi-Fi interface, a mobile device that connects with 4G and Wi-Fi, a small office that connects to the internet via two different ISPs via two CPE routers. So these scenarios are quite common. However, support for these scenarios has been like super poor, if at all present. So what normally happens, for example, in the case of mobile devices, is that you actually employ only one connection at a time. So even when you have like multiple interfaces, you are only using one single interface at a time. And if you try to do something like connect a local network to two different ISPs via 2CP routers, super likely you'd be lucky if it actually works. Obviously, from my perspective, and I believe this view is shared by many people, this warrants that support for these scenarios is improved in IPv6. So the best way to try to see or figure the challenges that are involved is to illustrate a super simple multi IPv6 scenario. What we have in this slide is essentially a local network. You could say like a switch that you have in there, and let's say that you have a small office and you want to do like a simple multi-homing setup, so to speak. You want to connect your local network to two different upstream ISPs. So what you do is you connect each of the CPEs to your local switch, for example. Okay. So what would happen in that scenario is that, of course, each of the CPEs from each of the ISPs would start sending arrays with all the network configuration information. Of course, we are assuming that Slack is being employed. And what will happen is that your host, or all of the hosts that are connected to the local network, will essentially aggregate the information that has been advertised by these two routers. That's what it's in orange at the bottom, and hopefully can be seen. So let's say in a single data structure, you get the information from all of the routers that are on that link. Now, it's useful to consider, what are some of the steps that take place when, for example, you want to be another thing, like in this scenario that you have in this slide, you see obviously the two ISPs. Each of the ISPs has their own a recursive DNS server, and just for the sake of the example, they have a web cache, and each of them are hosting an instance of the website www.example.com. So it's useful to consider what are the steps that are that need to take place from the perspective of the host before you can actually visit, for example, example.com in this scenario. So first thing that you'd have to do is obviously pick one recursive DNS server. In this case, you have two. You got one from one ISP, another from the other ISP. So once you have picked a recursive DNS server, then you should decide what is the source address that you're going to use for your DNS queries. Okay. Once you have that, then you'd probably decide what is the next hop that you're going to use to send your packets. And assuming that DNS resolution, went well, and you have, resolved example.com into a, quad A, into an IPv6 address, then the next thing would be to select a source address that you would use to send HTTP queries to the web server. And finally, before the packets actually get there, you have to obviously decide what is the next hop that you are going to use. Obviously, when you have like a non-multi IPv6 scenario, like simple scenario, just a single upstream router, normally you have these steps, obviously, but there are no choices to be made because you normally have like one single choice. Now, the problem or the challenge here is that as a result of the multi IPv6 scenario, now you have like choices for many of the things. Choices in terms of the source addresses, choices in the terms of the next hop, etc., etc., etc. So now this is kind of like a description. We have not yet got to the actual problem. but you might wonder, okay, what is the problem, or what's the underlying thing that ends up causing problems? Well, I believe the underlying reason is that Slack essentially operates on the premise that each router will advertise network configuration information. That the information that they advertise is just valid. It's valid for any system, or through any router that is on your local network. Hosts are expected to aggregate this information. As I mentioned before, you don't keep per router information, but it's actually, let's say, global information within your system. And essentially, it's up to the host to figure how to use that information. So you get a lot of information from different systems, and you are supposed to figure out, how to use that information in a way that works. Now, what happens in practice is that last part, using the information in a way that works, is non-trivial. Okay. So I'm going to cover like a few scenarios where it becomes evident that things break in a way. So I will start like with a simple scenario that I was illustrating or describing before. Essentially, we have a local network. You attach two CPE routers to your local network, to different ISPs. You get configuration information from these routers, and you put all the information. You aggregate all the information as Slack assumes that you would be doing. So, what are some of the things that could happen? One of the things that could happen is that, for example, you start sending packets using the address space from ISP-A, that is prefix A, through router B, which is the router that connects you through to the internet via ISP-B. So, if they employ or implement ingress-egress filtering, it's super likely that your packets are going to be dropped. Okay. Another thing that could happen is that, since you have two recursive DNS servers, because each ISP, advertise their own, you decide to send queries to RDNS server B, that is the recursive DNS server hosted by server B, but using addresses from prefix A. Now, if, let's say, ISP-B doesn't want to have an open resolver, most likely they are enforcing ACLs so that they will only provide the DNS server to their own clients, meaning you should be sending your queries from, ISP-B's address space. Another thing that could happen is, for example, that, when you get to resolve, or when you want to resolve example.com, you use RDNS server B for resolving that domain name into an IP address. In this particular case, where we are saying that each ISP has their own copy of this website, if you use RDNS server B for resolving that name, that is the resulting IPv6 address is going to be that of instance 2. That is the copy of example.com that is being hosted on ISP-B. But then maybe you might end up sending your packets to the using the address space of the other ISP. Okay, so you resolve a name with the recursive DNS server of one of the ISPs. It maps that domain name to an address that is being hosted by that ISP, and they could have, as in the previous scenario, just ACLs. They only want to use their cache to serve their own customers. But if you end up sending the HTTP queries with the address space of the other ISP, then your packets might simply get dropped. So what is probably evident, from all this discussion is that, at the end of the day, that of mixing up all the information that you receive from Slack routers will only work in super specific scenarios. But for the general case, actually, you should use the information provided by your router only as a, let's say, as a, atomic unit, so to speak. So if you're going to use, let's say, RDNS server A for name resolution, then afterwards, everything you do for that, like what is the next hop that you use for the DNS queries, what the source address that you use for the DNS queries, and also what is the IP address and next hop that you use for sending the HTTP request, should all belong to the same group of information. In that case, the one, advertised by, ISP-A. So how would, or what could we possibly do to, start improving the situation, so to speak? So one thing that the most basic thing that we could do is essentially say, well, rather than Slack host, like aggregating all the information and, mixing up everything, well, just keep per router state, per router information. So you don't mix it up. And that's like, at least the first step to do what I was describing before. So now you have, like, in the, in the same package, in the same data structure, so to speak, you have like the RDNS servers, the next hops, the local prefixes, and so on from one ISP, and in a different structure, the other one. Okay. Obviously, this requires a lot of changes that I'm not going to go into detail, because we would be running out of time. But obviously, you could. There's of course like a modification to Slack that needs to be made. Obviously, you'd probably need to implement policy routing, so that depending on the, for example, the source address, you use different next hops and so on. And what may be more tricky is being able to handle the DNS part all together with the rest of the information. Okay, like for example, making sure that if you use for name resolution the DNS server provided by ISP-A, that you also make sure that when you eventually use that IP address, like for sending HTTP queries, you also use next hops and IP address space, IPv6 address space from the same ISPs. There are some things that might possibly do for that part. No one of them like look like super trivial, but that's the problem that we have on the table, I would say. So then we are now going to move to another scenario, and this the previous scenario kind of like highlights the general things that we should do to to solve this problem. But then there is another problem, which is that, for example, in the case where you have like a multi-router, like in the same example as before, where you want to have two upstream routers, so that if one goes down or there's a problem with the ISP, you end up using the other one. Well, according to the current specifications, you might end up in a situation where you pick up, for example, an address from ISP-B, even when your next hop is not reachable, because reachability is not a factor when considering source address selection. So if you pick the source address without knowing whether your next hop is reachable or not, then once you have picked the source address, obviously you are tied to the router that you should use based on the consideration from the previous slide. Meaning that if you decide to use as a source address an address from prefix B, then you'd end up using router B, because it's the only router that can successfully route those packets. Whereas if at the point of doing source address selection, you would have considered whether the next hop is reachable, you might have done a better choice. One of the ways in which this could be improved is to add yet another rule to the source address selection RFC 6724. So that's a problem that is, like, let's say, more easy or easier to address. Another scenario, and when you look at the numbers, you might have realized that I skipped scenario 3 and 4. This is because I'm reflecting the scenarios that we have in our document that I will reference by the end of the presentation. So these are there's a discussion of these scenarios in the ITF draft that we produce. The other scenario that we are going to consider is a scenario where you have your local network. You have, let's say, two different ISPs, or they could be like, the essentially two connections to the same ISP, and let's say that, both of the CPEs advertise the same piece of information, okay? Or at least some piece of information, they advertise the same. That could be a recursive DNS server, or it could be, for example, a prefix. It doesn't matter. The point here is that you have multiple routers on your local network advertising the same information. Now, what would happen if, for example, one of these routers were to advertise that piece of information with a lifetime of 0, okay? According to Slack, that would cause the information to be completely discarded. And the reason is that, as I was mentioning before, according to Slack, you have to kind of like aggregate all the information together. So you mix everything into the same thing. So as long as a single router on your local network advertises a piece of Slack information with a lifetime of 0, that information should be removed, okay? That's obviously bad from my perspective. Like the fact that, for example, router B starts advertising whether a recursive DNS server or a prefix with a lifetime of 0 should only affect, the usage of that information with or via router B. But if from the perspective of router A, that the information being advertised is valid, then there's no reason for which you should like discard that information. So this is something that, it's not supported today. You could argue it's broken. And if you were to maintain per router state rather than aggregating the entire thing, the advertisements from all routers, rather than aggregating them, you could solve this problem. So ongoing work, what are things that we are doing? And disclaimer, this is not the first time that somebody thinks about this scenario, and this is not the first time that somebody tries to come up with a solution, okay? What we try to do in this particular case is do two things. First one, document the problem, so to speak. But I mean, the problem in a way is known. What we specifically wanted to do here is to define a specific set of cases that any solution in the space should address. Meaning that if those are addressed, even if there are other problems that are not solved, okay, that's good enough. So that might mean, or the goal here, or the hope, is that we might not get like a perfect solution that might solve all of the problems that would come to mind, with multi-homing and everything that you could think of, but we could come up with a solution that at the very least, addresses and solves the scenarios that, I was discussing throughout this presentation. Those, let's say, test cases, if you wish, are documented in the first draft Gont B6 Ops multi-IPv6. And there is a second document where we try to specify the protocol updates that would be necessary, to actually address all of these scenarios. So conclusions from my side. I believe it's well known that multi-IPv6 scenarios are broken. This is something that everyone whenever we get to talk to people about this, it's like, yeah, well known. We know it's broken, but we in a way we haven't yet figured out like a workable solution to at the very least address the long-hanging fruit scenarios that I was describing throughout this presentation. Obviously, it's my belief that support for multi-IPv6 scenarios should be improved. not necessarily make it perfect, but at least be able to address those scenarios. And the obvious thing, that should be noted here is that whether we like it or not, quite a bit of these problems essentially get off the table when you implement other solutions that probably in this working group we don't want to consider. So that's it from my side. So I guess we have some time for comments and questions.
Okay, we have about a minute and a half. Thank you, Fernando, for joining us anyway, all the way from Argentina. There is David Lampater.
I'm here at the mic.
Yes,
David Lampater, FR routing and ITF participant. I'll skip the part where your presentation is not quite right, because there are two questions that I would really like to ask the room here. The first one is, what do we actually need to support in terms of complexity of the network that has these multiple uplinks? In your slides, you only have the two routers, but do we need to support this for small enterprise networks that have a few, like a handful of routers that need to coordinate this between them? And this is something that the ITF really needs input from operators on. Like I'm participating in these discussions and we can't answer that. And that's why I would like to pose this to the room. The second question I would like to pose to the room is, what level of functionality do the operators and everyone here need from the hosts in selecting between these multiple uplinks? Because that's also open work that we don't have quite done. And we need input here from operators and people running the actual networks. And if you can send an email to the ITF lists, you don't need to keep reading the ITF lists, just send a one-shot mail and forget about it later. But please participate in the ITF discussions about this. We need your input. Thank you.
Thanks for putting it to the mailing list, because we really don't have time to do it here, unfortunately. The next one on the queue is Jan George.
Hello, Jan George, 6Connect. Ciao, Fernando.
Hi.
So I was wondering if you add to all this complexity also the problem that we're trying to solve when the operators are deciding to change the prefixes every 24 hours. How can this even be solved at the end of the day?
I'd say it's sort of orthogonal.
Is it?
I think so, yes.
Okay, thank you.
Okay, Warren.
Sure.
We really have to be short now.
Warren, Kumari, Google, isn't most of this solved with provisioning domains and virtual subinterfaces?
Is it actually implemented and deployed? So from what I've seen, like at least at home, not really.
Okay. Jan Linkova, a quick comment. We did have discussion about treating every array from every single router as a PVD. So if you have two routers, you get two implicit PVDs. However, that causes a problem if I want a device which, for example, does not want to be a full router, but want to send RDNSS separately. And I have another router, which is a router, but is not capable of sending RDNSS. So there are scenarios where it would not work as an implicit PVDs.
Okay, after this gentleman, we have to close the mics. No, it's fine. After you.
Hi, Fernando. Rodrigo Arenas from .cl. Talking about personally. In scenario one, which OS system you use? Because one of the users have this problem. In quarantine, I have two ISP with a dot prefix IPv6. And what happened to me also is first come, first use it, just that way. And after working, I tried to use both of the plans in the network. It was difficult to do that. And so what operating system you do in the first scenario you describe? Because you say is uses one prefix to another router, but in what operating system do you do that?
So I have checked like with multiple of them, like virtually all of them. And, you know, at the end of the day, they end up doing what I described, like mix up all the information, and you get lucky if they use all the information together. A lot of the times what happens is that you just get one of the ISPs used and the other one is like, you know, forgotten completely.
Okay. Thank you.
Okay, thank you all for your questions. And then we have Éric Vyncke with IPv6 mostly experiences at industry events, and also Warren Kumari.
So, oops, pretty loud here. Sorry about it. So the two of us, both on to the industry event, big one, and we are trying to replicate there what Andrei has been doing here for many, many years. So, industry event, one from Cisco, I work for Cisco, and one from the IETF, and Ryan will talk about it. A lot of the slides are coming from a colleague of mine who is part of both the Cisco Live NOC and the IETF NOC, which is Joe Clark. And as I get some time to prepare the slide, I enjoy playing with AI. And you will see some very naively generated AI images there. So, first AI generated, right? The goal is at the top of the hill, the mountain, IPv6 only, where the sun is shining. And you are coming from IPv4 only at the bottom. Typically, you will go to your stack and IPv6 mostly. It's near the top. Notice that I was unable to fix the typos generated by AI. Both the stack and mostly are misspelled.
The path also doesn't actually get to the top.
Thank you, Warren. Yes, he was my colleague, right? On this one, that's not really anymore. Anyway, so you know about IPv6 mostly. There's basically two classes of hosts being there. One which is IPv6 only capable, and they will not use any IPv4. That's the trick. And the other one are either IPv4 only or dual stack. The goal basically for this step is to foster IPv6 adoption. I talk to many customers, that's part of my role in Cisco, and going from IPv4 only to IPv6 only, that's a no-go, right? So if we tell them, yeah, and dual stack is kind of complex, what we are pushing right now when you talk to customers and enterprise customers, right, big banks or whatever, is to go with IPv6 mostly, because it's doable, basically. So another AI generated, if somebody in the room does not recognize herself, then I failed. The goal is really to reach IPv6 only again. IPv6 capable host, if you are doing this, you rely on client level address translation, CLAT, and you receive the prefix. Normally, the best way to do it, and there are documents, I think it's in V6 Ops or 6man, to only use the DNS, the array recognition and distribution of the V6 prefix, for the NAT64 prefix, to be honest. And those hosts can also decline to use IPv4 address by using option 108 in DHCP-v4 request, right? If the DHCP server reply, yes, you can not use IPv4, then they do it. There is a draft at the IETF in V6 Ops, again, by the big players, right? So Ondřej, we see here, Jen, who is here, and Nick, who lives in US, so he's not here, and not remote, as far as I know. The Explorer is basically recognition for the guy, again, AI generated, for the three people, right? And so Ondřej and Jen, you are there, somewhere on the picture, if you can recognize yourself. I cannot make you completely correct, Ondřej, right? But okay, again, generative AI is just this. So Jen and Google, Ondřej here, for a long time, for mostly 3 years, we have the benefit here at RIPE of being tested and tested there. But there is also another big deployment in a university in London. It was explained during the IPv6 Council in the UK of last year, and there's about 20,000 students using IPv6 mostly, so which is cool, right? So it's typically something you can deploy. But this was just a refresh. What you want to know is what we did in industry event. Okay, not industry, but in both cases with geeks like us in the room. So Cisco Live is obviously an event organized by Cisco. It took place in Amsterdam early this year, and the picture is not AI generated, this one, so it's nicer. About 20,000 attendees, including most of it 3,000 from Cisco, but a lot of people like customers, partners, and so on. They go there for technical sessions. If you have been there, normally you like them because it's mostly technical. There's also an exhibition, blah, blah, and so on. One key point, obviously for a network company like Cisco, it's pretty important to have a decent Wi-Fi, right? Because guess the brand of the Wi-Fi access point, guess the brand of the routers used in this premises. So it must be running. So we have a NOC team that stage this months in advance, okay? And they were able to change, at some point of time, there was a Wi-Fi problem. They were able to change a lot of access points during the night. So there is a big, big thing. So we prepare. But you will see, we have at least 1 or 2 lessons learned on it. Even with the best preparation, there are some failures sometimes. Not big failures. And we there, and I'm pretty proud of it, to say default SSID is IPv6 mostly, right? Pretty much like here. We have public IPv6 space, easy to get, of course, and private IPv4 inside, right over the Wi-Fi. The core team, the NOC team, most probably you know Andrei Yushchenko in the middle. That's a colleague of mine based in Brussels. Normally he's online as well. So that's it. Edge design, so between basically the internet and all the Wi-Fi and campus thing. 2 cores, right, obviously for high availability. We are obviously using ASA1K, both for doing the NAT 4.4, right, and the NAT 6.4. And you will see that's something that was kind of a small issue there. And you get the bandwidth on the top, bottom right. NAT 6.4 design, not a big surprise, right? NAT 6.4 translator, as I said, ASA1K. We have a DNS 6.4, and we are using our umbrella. Umbrella is basically open DNS, make a product. And we are using CLAT and DHCP on the DHCP server. And we are using the well-known prefix for NAT 6.4. So nothing very specific here. 2 minor problems. We were planning for failures. We were not planning for success. Right? The NAT 6.4 pool was exhausted too quickly. Right? I mean, this is a nice thing, right? So I would not say it's a failure or not, but it was a small issue. So they changed the timer, increased the pool, and so on. So everything was fixed over the night, right? So this was pretty nice. Also, a minor problem is that some technical session included live demo. So how we do live demo, basically we connect to a VPN tunnel to data center in San Jose, California. And pretty much like Ondřej explained about the DNS thing, some split tunneling configuration, because each and every demonstration was using a different kind of split tunneling policies, were badly configured for an IPv6 mostly when you are running on a Mac. So on the Mac, typically, you can use IPv6 mostly. So at least we got a failure plan, and you can connect to Cisco Live-Legacy, and then you find a normal dual stack network, and everything was fine. That's basically the 2 issues we got. Numbers. Remember about 20,000 people, but many people are like me, needing 3 addresses, 1 for my Android phone, 1 for my iPad, and 1 for my laptop, right? So the numbers of people connected based on the MAC address. 20,000 people, or 20,000 devices actually, use IPv6 mostly, and 24,000 were using dual stack. We all know that the major operating systems does not support IPv6 mostly. I guess this is mostly those one. Okay. Oops. This is last year. Ah, shit. Sorry. You have nothing. This is 2024 numbers. The top one is the traffic in IPv4, and the bottom one is IPv6. So last year, in 2024, we were about 44% of V6 traffic over the Wi-Fi. We were kind of already happy on this. But this year, 44 terabytes of IPv4 and 45 terabytes of IPv6. So slightly more than 50% with normal user, right? Using normal application, which is pretty cool. Of course, my feeling as well is that most of us now are using zero trust networking. So, or using, for instance, the big email provider that are V6 capable. Or in CDNs, like also V6 capable, right? So that's pretty cool. And in total, over the connection, this time not over the Wi-Fi, but really on the link, just to give you an idea, it was about 90 terabytes. But it was just one event, right? We intend to do it more and more. Another big event that I like as well.
Hi all. So where's next? I'm Warren Kumari. I'm one of the IETF NOC volunteers. And a little bit of background, we are almost entirely a volunteer-driven NOC. We do 3 meetings a year, once in North America, once in Europe, and once in Asia. And we have between 720 and 900 people in person at the events. For a very long time, we've been doing a default SSID, which is dual stack, but we've wanted to do an IPv6 mostly solution for a long time. It's taken us longer than we would like, to some extent. More mic? Cool, better. To some extent, it's because a lot of us are volunteers. We also have most of our equipment donated, and so we needed to replace Juniper routers with firewalls to do the NAT64 functionality. But at the meeting before last in Dublin, we did an initial test and had some working IPv6 mostly. And then we decided in Bangkok we would do a much larger test. The way that we generally build this is the Tuesday or Wednesday before the meeting, we come along and we build and set up the network. And that's what we did. And IPv6 mostly was just a small slice of this, but we tested it and everything seemed to be working fine. And then on the Sunday evening before the meeting started, one of the NOC volunteers connected and their device wouldn't actually connect to V6 mostly. And what we discovered was, because Apple's do the IPv6 only stuff really well, we hadn't actually built an IPv6 mostly network. We'd built an IPv6 only network. We just hadn't noticed. Turns out we weren't actually forwarding the DHCP discovers. And so we fixed that on Monday morning. We needed to add this particular bit to the NAT config. It shouldn't be needed to make the DHCP discovers work, but it was needed. Hadn't been needed in previous testing. But anyway, did that, asked a bunch of people to connect. We had some fairly good usage. Fairly much everybody who used it was happy with it. And so our plan for the upcoming meeting in Madrid is to make the default network be IPv6 mostly, and hopefully everything will be good. We did notice a few small issues. Some people who have sort of corporate protection software on their laptops don't seem to be able to load images on Slack. We also discovered weirdness with the Mac native version of SSH. If you have both an A and a quad A record and you try and force SSH to use IPv4, it doesn't actually work. But we believe that that'll be fixed in the next macOS, and we have a little bit of time for, Next slides. Yep, Tommy Pauly from Apple managed to fix the weird SSH native macOS client. And I believe that that is questions. Summary and questions.
So, summary.
You want to do the summary?
Yep. So, summary of this. If you pay attention, everyone can deploy IPv6 mostly. It's not that hard. There's some minor difference, so you need to learn. We have learned. Some issuing limitation, some split link policies, Slack wilderness, as you just explained. Some mobile device management also prevent you to use the right DNS6.4, so then it doesn't work too much. And we know all of us are expecting to get a new Windows release, so we can make this working at 100%. That would be pretty cool. And nice, successful AI-generated image, right? This one. Not like the previous one. Question?
Yes, there is a question from David Lamparter.
David Lamparter, Chaos Communication Congress, knock 15,000 hackers. We deployed this during the event. Usage of v4 addresses dropped to 25%, so 75% of devices did not request an IPv4 address anymore. Why did we deploy this during the event? Our routers did not support RFC 9047 for EVPN for neighbor discovery. If you try this and you use EVPN, make sure your routers do 9047. It was very painful.
Thank you. Do you have any idea why only 25% were using IPv4? Is it the host OS?
This is a hacker event. There's a lot of weird devices. So I would assume the 75% is all like Apple phones, Android phones, normal laptops, and the 25% is like, I don't know, an ESP8266 doorbell, you know, that kind of thing.
Yeah, I was guessing the same. Thank you.
Okay, Jan.
Jan Linkova, thank you very much, right? Thank you very much for telling people that it actually works. And I'd like to go back to this amazing story of fixing SSH on macOS, because yeah, I was there troubleshooting that stuff, right? I can't even imagine how we could have fixed that. People in the room, we spent like a couple of hours looking that we got Polly involved. And in like 1 hour, it was a code change sent out for review. And it was quite tricky thing hidden deep inside like library of operating system. So it's very important to do that kind of stuff in the places when all right people present before we actually going out. And so we just got it recorded that we're going to see it in Madrid, right? So you kind of committed, thank you, Warren.
Hoping for. But yeah, I mean, this was a really good example. What it was is we had some weird geeky people who had weird SSH configs that probably people in Apple would never have seen. We ran into this thing at the IETF. We happened to have Tommy Pauly, who's one of the kernel people who works on the Apple stack. We got these people together because we did v6 mostly at an industry event, found the issue, fixed the issue. You know, Tommy had his editor open. We fixed it while people were standing around. And hopefully in the next version of macOS, it will be fixed in production. Andrei.
No, it was actually that gentleman there.
Sorry.
Oh, thank you. Brian Candler. So Warren, I noticed on your slides you show DNS 6.4, and there's DNS 6.4 running on the IPv6 mostly here. Is that still required? So anybody who gives option 108, do you still need to fake DNS responses? Because it has actually caused me a few problems. I need the real IPv4 address, not a fake IPv6, for example, for my VPN. So.
I think Jen has the...
Yes, it depends. We try, like, plenty of operating systems, like, which uses option 108 would be happy with prefix 4 being advertised. What would be broken is devices like which do not process prefix 4, namely currently, I believe if you take Chromebook and enable option 108, it would not take prefix 4. So Apple and Android would be happy. Or if you have, for example, Linux laptop and all your applications are happy with v6 only, but you do not have Celat, I believe Linux. Oh, okay, sorry. I'll shut up. Yeah, so basically it would mostly work, and we have a document actually in V6 Ops currently, which emphasizes, please, 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 if you develop your stuff on the end host, please take Prefix 4, don't rely on DNS64.
Yeah, thanks. Because if it's Windows, for example, it's just going to ignore the whole Prefix 4 and fall back to dual stack, and it's fine.
Okay.
Thanks.
I'm very sorry, Andrei, but we're over time already. We're in the break. Is it how many seconds?
Do it, yeah. I have basically many comments. Thank you very much for the presentation. I'm really glad that we are not the weird RIPE meeting network, that other events are doing the same thing and then people cannot complain. It's your broken RIPE meeting network. It's now broken also at Cisco Live. That's good to know. But it actually works. No, my comment was, at RIPE meeting networks, of course, it's smaller than Cisco. We have about 40K NAT64 sessions as a maximum of the week, which means it will easily work with single IPv4 address. So I believe that the fact that you run out of v4 addresses in your NAT64 pool probably speaks something about the quality of the NAT64, that it probably uses too many IPv4 addresses, I think.
Okay.
And just as a very last comment, thank you very much to RIPE for being the sort of leaders in this and being the first big conference to have done it. So.
Thank you, Eric and Warren. It's time for coffee. Get out of here. Or that. Somebody's found a necklace. If you're missing one, go to the desk. Thanks, and remember to rate the talks.
Are you ready?
I think I was looking for a t-shirt.
Good morning. Welcome to another database working group. Looks like we still have a few folks filtering in. We have a really great setup today. We have obviously our operational updates from RIPE NCC and Ed. We have some updates also on our authentication. And then we have some NWIs, which we have a few things that are going on from that perspective, as well as, we'll jump into some other business that we have opened up. So everybody awake this morning? I think we're good. Let's see. Can we get the doors closed? Great. Randy's here. We can get started. So with that, we'll kick this off. Ed, with our operational update.
Thank you. Good morning. Thank you, William. For anyone who doesn't know me, my name is Edward Shryane. I work as a product owner on the database team for the RIPE NCC. Here's the operational update for the RIPE database. So in this update, I'll be going through progress since the last RIPE meeting, planned work between now and the next RIPE meeting, and I also have 2 proposals to share with you. Here's the rest of the team, just to acknowledge their hard work since the last RIPE meeting. It's gone into the update. Progress, we've had 4 WHOIS releases. First in January to add API key authentication as an alternative to MD5 hashed passwords that we're phasing out. We've added an NRTM version 4 client to complement the server implementation we're running. And finally, we got some feedback from the working group to extend the length of an email address to the maximum allowed by the RFC. In February, we fixed a small bug parsing API key details. In March, we implemented relation searches in ORDAP, which is the equivalent of hierarchical queries in WHOIS. So that closed the gap between the 2 protocols. We added a warning if members by ref is changed on the set. It can break your updates in ASNs, and sometimes there can be quite a gap between the 2, so it's quite hard to figure out what happened. If your ASN is a member of a set and you change the members of by ref, you can break the authentication there. So now you have a warning in the response when the set is changed. And lastly, in April, WHOIS 117, we made some changes to the init-num status hierarchy validation and some other improvements to ORDAP and NRTM version 4. And just to be a bit more specific about the init-num status hierarchy changes, we do, with the help of the registry team, we look at the init-num and init6num status hierarchies in the database. We made some changes to align with the policy text. This is our interpretation of what the text says. There's now only 1 level of aggregated by LAR allowed to be consistent with assignments. LAR partitioned PA, which is meant for LARs to divide their internal network. It doesn't make sense to allow that under sub-allocated PA, which is intended for third parties. Finally, not to allow LAR partition PA under assigned PA. It doesn't make sense. The assignment should be the very bottom of the tree. It does affect a handful of existing data in the database. The registry team are following up and working on that. And just to be clear that the WHOIS implementation, it's very important that it complies with the policy text, because users will take it for granted that if WHOIS allows something, then it must be right. But if you do notice an inconsistency, please let us know directly or by the working group. And Dennis has started a discussion on the list recently, so if you're interested, please follow up there. Unfortunately, there's 3 WHOIS outages since the last meeting, and apologies for that. In March, there was an interruption to mail updates.
We made a MariaDB upgrade to the latest long-term support version, and we dropped some mail messages. The script that we're using on the command line was returning an error, but it meant that mail messages were not being put into the database and were dropped. We're going to fix that by replacing the command line script with integrated SMTP handling. So XIM on each of the mail servers will talk directly to Whois, and this hopefully will pay off in the future as well when we run Whois as a managed service. We can use SMTP there too. In February, there was a mailing to the list about an increase in domain updates with long-running DNS tests. We believe that was a spike at the time, but it's been happening consistently since then. We have made some, we've tried to address the capacity issues by doubling the worker pool in the back end. ZoneMaster is responsible for verifying, validating the domain DNS information in the domain object, doubled the worker pool. We made a small change to the web application, so we wait long enough for Whois to tell you what exactly happened. So it's a bit more meaningful, the error message. We are also planning to wait for the maximum time for ZoneMaster to return, but still there are some open issues. We want to make the queuing a bit more fair, and also drop long-running tests. If you're waiting for a long time, there's no point continuing to wait. So we're talking with the DNS team on those improvements. And finally, we do a switchover of the primary database in production every month to patch servers and also to test for disaster recovery. And unfortunately, in March, we had a few minutes of downtime for updates, and we're looking into the root cause. Some statistics on Whois: nearly 1,000 allocated assigned PA INET nums now, and in particular 500 out of 12,000 /24 allocations. So seems to be doing its job, seems to be good uptake of that new status. There's 84,000 abuse addresses. We're a little bit behind on validation. We need to validate all of those every year. We've already increased the rate, and we're working with the registry team on getting on track to do that. And just over 10% of LR organizations are synchronizing their users to the maintainer, so you don't have to maintain your users in two places. Useful feature. We reached a milestone in the non-auth database. We're finally below 50,000 objects. There was an 11% decrease in the past year, so slowly decreasing. Just over 100 INET nums with aggregated by LIR that was introduced last year. The intention here with the status is to reduce LIR efforts in registration and maintenance. Slightly disappointing uptake, but it seems like a very useful status that you can aggregate assignments, especially given there's more than 4 million assignments in the database. This seems like a good way to do some, to reduce that number. And finally, we reduced the number of undeliverable email addresses in the database. As I said at the last RIPE meeting, we're dealing now with soft bounces, where there's the mail delivery failed temporarily. We now retry those after a day. And also, if an email address is undeliverable, but it's no longer referenced in the database, then there's no point in keeping that recorded as undeliverable. So we've also removed that. And there is an ongoing effort across the company to deal with undeliverable email addresses. So this we'll be seeing some improvements. We're working on it, not just in Whois. There was some refinements to the acceptable use policy. There was a discussion last year about how we implemented the daily limit according to the acceptable use policy, and that was clarified. We got board approval to make some changes. There's also some minor changes that we also made at the same time, also to clarify the text of the acceptable use policy. It's now live on the website. And because our documentation repository is public, you can do a diff on the changes as well. And they're all listed there. We added a feedback questionnaire. This is something that's already live in the RPKI dashboard. We're also adding it to the query page. We want to hear your feedback. So we will ask, there's a feedback form, ask a couple of questions. You can rate us out of 10, and there's space to put some text in there to give us some feedback. We're only showing it to logged in users. Feedback, we don't keep your email address, it's anonymous, and we will be aggregating the scores across the company. We'll be feeding those into the company scores, the NPS scores that Hans Peter Holm was talking about yesterday. And feedback, we are very interested in feedback to improve the service. So you don't need to wait for a right meeting to let us know how we're doing. API keys, a very important alternative we can to authenticate with. It's available since January. You can create them using your RPNCC Access account. There's a new menu on the left-hand side called API keys. Allows you to create, list, and revoke keys. To authenticate updates, you link the API key to the maintainer using your SSO attribute. You can use HTTP basic authentication or split the API key into username and password. And it's restricted to the environment they're created. So you can do this in test, RC, and training also. And the keys you create there won't be usable in production. And we do notify you before and after the key expires. And we've created extensive amounts of documentation. There's a labs article. We've integrated it into the database documentation, and our learning and development colleagues have created a micro-learning course on how to use API keys. Upcoming changes. So I'd like to stress that this is provisional, and I'm looking for feedback, and I'd be happy to make changes according to feedback and the preference of the working group. So most important, we are getting rid of MD5 hash passwords this year. We published an updated timeline in February. Right now we're working on removing inactive passwords. So that is passwords that haven't been used since the beginning of 2024. About 17,000 maintainers are affected. We will start next week in processing those. We've split those into 4 batches. And we will let those maintainers know in advance that this is happening, give them an opportunity to remove the password or switch to a replacement. About 2,000 of those have no alternative. So if they do not take action, they will be locked out of their maintainer. So in order to deal with that, we've improved the forgot maintainer password process. 2/3 of requests to regain access to your maintainer are already successful. But we want to reduce the load on our maintainers and on the registry team. So we made some improvements to that process to increase that. After the right meeting, we'll be working on active passwords. There are about 2,000 maintainers using passwords actively, and that accounts for just over 1/3 of all updates. So it's important to give this group as much notice as possible. So after the right meeting, we'll be emailing them also and letting them know that passwords are going away. They need to switch to an alternative. And there are some related changes. Test environments, we won't be asking for a password anymore. We'll be removing passwords from mail updates and dropping HTTP support from sync updates. Just a table of progress so far this year. Authentication methods in use. A couple of things to note. Password authentication is not really going away. Still stubbornly high at just over 1/3 of all updates. Interestingly, client certificates have made there's been a real increase in the uptake of client certificates. And unfortunately, API key usage is remaining at about 1%. So there's some work to be done to encourage adoption of the alternatives before passwords goes away. OAuth2 support, my colleague Adonis is going to be talking about that in a minute. But in the database team, we're integrating support for OAuth2 into Whois. For ORDAP, as I've said, we completed relative search. We are going to work on reverse search. This maps to inverse queries in Whois, so that will be now available. Something similar will be available in ORDAP. We want to also work on bulk ORDAP. So this will be providing a database dump, a daily database dump in JSON format of objects in ORDAP format. And the advantage is that it will be completely ORDAP in JSON, and an alternative to using NRTM version 4 or the existing database dumps. Transparency report, there was a request last year to report on the gaps between the RDAP and Whois, and we found that the biggest gap is lack of support for IRR types, and we are investigating with the other RIRs how to close the gap there, but it's nothing to report yet. Administrative status, this is an issue with our implementation for a while. It's listed on the repository for lookups in region but not allocated. So they are reserved in the extended delegated stats. We now will be returning the parent IANA allocation to /8 with status administrative rather than not found. And finally, there is another scenario where you may still get a not found in your RDAP responses. For resources transferred out of region, you may still get a 404 there because the other regions delegated stats have not been updated yet. Right now, we're only updating that list once a day, but we're going to move to checking hourly. So the other RIRs update their stats at different times of the day. So we're going to be checking more frequently to pick those up as soon as they're available. NRTM version 4 mirroring, I mentioned we implemented a client. We now consider the server implementation as feature complete. It's been running in production since 2023. We also implemented an implementation report for the ITF, and the draft RFC text is in last call, so there's been good progress there. One upcoming change is we're going to add CDN support because we expect increased uptake of this protocol. We will need a CDN because some of the resources are quite big, the snapshot in particular. The upcoming IRRD software will support NRTM version 4, but it's something you need to make a choice for and configure manually. One thing we've wanted to do for quite a while is not to apply the daily limit to your own data. Makes sense. Users should not be accounted for their own data. So if you are logged in to SSO or authenticated using an API key, we know who you are, so we will not account for your own personal data against the daily limit. It's supported by the REST API, RDAP, and the database query page. It feels like an obvious thing to do, but in reality, it's not going to help in a lot of the case because most of the queries are unauthenticated on port 43. But this is a reason to move to using authentication for queries. The activity plan, just to mention our commitments for this year, there's a couple of things there. I think I've mentioned everything, but it looks like we are on track and we are addressing the commitments that we made for this year. So finally, I have 6 minutes left. I just want to talk quickly about 2 proposals. Firstly, in looking at the statistics for the non-auth database, it's been around now since 2018. It contains non-authoritative data that were created without authenticating against any resources in the database. It contains a lot of auth-num objects, ASets, routes, Route 6. No new objects can be added. Very few updates every year. And it's slowly decreased in size, but it's not going away by itself. So I'd like to ask a question. Is anyone still depending on the data in the non-auth database? The objects are returned by default, so the non-auth database is there for query responses. It'll be checked. If you are querying directly for the key, you will get that data. But also if you query for a prefix, for a resource, if there's an associated non-auth route, you will still get it. But counting the query responses, you are very, very unlikely to see an object from the non-auth database unless you're looking for it. So we have separate database dumps and split files for non-auth. We have a separate NRTM source. So finally, Aaron, just to point out that Aaron retired their non-auth database in 2022. I'd like to ask the community, is it time to retire RIPE non-auth, or is it a bit premature? So I'd appreciate your feedback on that. Secondly, UTF-8, I presented on this at RIPE 89, and thank you for your feedback. The response from the community seemed to prioritize the most frequent feedback was that to focus on a subset of UTF-8, to pay attention to normalization, and also human interoperability is very important. So in supporting UTF-8, we don't want to make it harder to interoperate using the database. There has been a lot of history around internationalization in the database, and just like to point out that clearly over the years there has been a lot of interest in it. We haven't made a lot of progress, but I believe we can learn from the feedback that we got in the past, and whatever solution we come up with needs to take this history into account, I believe. And finally, the proposal, I'd like to propose that we allow UTF-8 somewhere, and to begin with, in description and remarks attributes. I promised a problem statement at the last RIPE meeting, and this is something that I will publish after this RIPE meeting. The functional value of this change would be to allow operators to add localized messages in their own language for their region. The technical reason would be to put UTF-8 somewhere in the database, but at a minimal scope and impact for the RIPE NCC and also for the community. We want to deliver something that's of value to our users. And we want to gain some experience with UTF-8. And to stress, names and addresses are not affected. We do not want to touch that yet. It's going to require a lot of work. And specifically, it's not intended to internationalize personal data. You should already not be putting personal data into description and remarks attributes, because we're not accounting for that in the daily limit, and it's not filtered in responses. We do not want to impact on the RIPE NCC operations, so propose a review before we make any changes internally. And we don't expect an impact on database functionality, but this is something for discussion. So as I said, I'd like to publish a problem statement on this for discussion, and leave future work to support other data types or attributes. So I'd welcome any feedback. So that's it. Thank you for your time. Questions and comments? I don't see anybody. Before I disappear.
Yes, please make sure to state your name and affiliation.
Kenji Shioda, Nebula Online. Hi. You were explaining, sorry. You were explaining a lot of reasons to discard of the non-auth database. Could you think of any reasons to keep it? Thank you.
That's a good question. I don't think it's for me to say. There is an overhead in keeping it, so there are reasons to get rid of it, as you said. But I'd like to know if anyone is depending on it to come forward and let us know. It's already been retired from the Aran region, seemingly without impact. So it would be good to know before we do similar what the impact could be in this community. Thanks for the question.
Rüdiger Volk, retired and, well, okay, formerly was user of this. Since the Aran only had very recently introduced true RPSL IRR, kind of their non-auth also was really recent. So kind of that is a very short-term temporary thing, I think does not predict anything about the long-standing data that has been split out into RIPE non-auth. And since I'm not in the operations anymore, I cannot tell whether, say, the customer relations that were actually meaning that non-auth was a usable database, is still in place. Kind of RIPE NCC has a tradition of looking at their data and actually analyze whether something that's supposed to go away is still being used and to which extent. I would suggest to consider what you can do in that direction. Else, I would see a pretty big danger that someone is actually depending on it and will, will not kind of note that you are asking, well, is anybody using it?
Thank you for the context, Rudiger. I think it's very important. We can only see from the query rate how much the data is being returned, but there is a lot of data there for a long time. It's not going away by itself, so we do need to be very careful before we take.
Yeah, well, the kind of and I don't remember whether you decided to deliver the non-auth objects by default when querying the database, or where it probably would be a useful thing to not deliver by default. If users actually have to ask for it, you would see that. I'm sure the tools that I left behind, and that probably are used in some way still, actually explicitly decided per customer relation whether that customer relation was using the non-auth or not. And you would see that in your logs.
Yeah, we could certainly do that. And one change we could make is not return the related route object, for example, something the user may not have asked for or want. But it means then there's a behavior change between the RIPE database and the non-auth database. So something to be considered. Thank you.
Lutz Donnerhacker, I'm taking the head of ICANN at large for me at the moment. We are talking about request to data access services, and we have this problem in more global way because the structure or the idea behind the service is to centralize data for allowing bulk access. So we are moving data out of the original legislation area, put it in another one. It's quite difficult. We have the difficulty in ICANN that we can't introduce a system like Ayana is doing. They just refer to the contract they have and say, here you have the next server, please have a look there. It works much better. If possible for midterm consideration, not short term, it would be fine if RIPE is offering for their region, because we have also different legislation areas here, to offer that we can store some information in a delegated form that we can show that the distributed or hierarchical database is possible, and it will influence discussion about the whois information or the registration data information at ICANN level. Thank you.
Thank you. Okay, if there's no more questions, I'll leave it at that. Thank you.
All right, it looks like there are no more questions. Next up, we have Adonis talking about implementing OAuth 2 in the RIPE database.
Good morning, everyone. Sorry, Ed is a little bit taller than me. Yes, my name is Adonis, and I work for the RIPE NCC. I'm part of the software engineering team, and today I want to talk to you about OAuth. There was a slide mentioned yesterday at the NCC Services Working Group, and Ed just mentioned it. So let's see what OAuth is. So OAuth stands for Open Authorization and allows certain parties to access and manage resources on behalf of other user without exposing their credentials. You probably have used OAuth in some sort of way yourself, with or without realizing. An example is if you're trying to use Spotify and then you don't use your username and password or create an account, but you use another provider. So you might use Google in order to use Spotify, but your credentials are with Google and never leave their environment. So this standard, and since, as I mentioned, since this year, with the deprecation of MD5 passwords, we're gonna, we offer the use of API keys. And as an alternative to that, and after discussions in the mailing list and with speaking with members of the community, we want also to enable an OAuth solution. And this, we see it as an alternative to API keys. So we see those two services living next to each other, and they're not a replacement. So the difference between API keys and OAuth, first with API keys, a user generates a key themselves and then they share it. And this may have some problems if it's shared not with authorized parties or with any other means. But with OAuth, this process is done through an authorization flow, so no actual, so it's less prone actually to this type of errors. When it comes to application identity with OAuth, each client app gets a client ID and potentially a client secret. We know who is accessing what, so there's an audit trail, but with API keys, there's no such built-in mechanism to see who is doing which. With scope, both API keys and OAuth, they have some fine-grained permissions, such as read-only or write for specific parts of the RIPE database. And in terms of lifetime, API keys can be configurable up to 1 year. And with OAuth, we use tokens. There is an access token that has a lifetime it can have a lifetime of up to 1 hour, and a refresh token up to 1 year. So a little bit more on OAuth. It works with authorization flows. So this is the process that a client app obtains authorization from a user to access their protect data on a resource server. So what that means in the case of the RIPE database is that a client app is the process that client app takes to access and edit the data of the RIPE database on behalf of a user. So in the past few months, we've conducted some user interviews to see what members of the community would like from an OAuth solution. And they expressed that they would like to authenticate on behalf of other users. They would like to make changes through web application, or they would like support from for SQL command line scripts. They would like minimal user intervention and then having different scopes. So the scopes, again, are the different permissions. And based on these requirements, we looked at the authorization flows that are available. And I'm going to go on each one in more detail. So the first one on the left is the authorization code flow with Pixie. So this is recommended for web application, mobile applications, and single page applications. This is where a user logs in through a secure browser redirect, and the app exchanges a special code and for access and refresh tokens. And this flow is also protected against code interception attacks via Pixie. So this means that it ensures that the application that starts the authentication flow is the same one that finishes it. Then the second one is the device code flow, and is designed for tools or services that don't necessarily have a browser. And the app gives a specific URL and then a code, and then the user has to use another device to authenticate and grant access. There are some security concerns with this option, but one of the good things, some may say it's a bad thing, but you can't really authenticate on behalf of other users. So in this example, you've seen it more on TVs, for example, where you're trying to log in and you have to use your phone or another device to do so. Then the third flow, the client credentials flow with token exchange, is actually machine-to-machine communication. So the app authenticates itself and requests a token, and that token is then exchanged with a token with different permissions. So this flow has actually a lot of flexibility, and it can be set up in a way that the user can have edit or write access and with different policies. But this flexibility comes with sort of cost because it requires quite some development work from your end and also from the RIPE NCC. When looking at these three flows, the authorization code flow with Pixie and the device code flow work out of the box with Keycloak that we use, but then the client credentials flow will be something that has to be made out of scratch. So based on the requirements that I mentioned in the previous slide, we matched the different flows and all of them can work. So all of them can be adopted, but of course there's pros and cons to doing each one. From our standpoint and seeing what we've had an open house and last month, and also we have done some demos here and had conversation, and we're thinking of starting with the authorization code flow with Pixie as the first solution, because it offers interactive and offline use. The sessions can be app specific, or it can be for all RIPE-NC apps. It's quite easy from a user point of view because they log in into a portal and then they authorize, they provide their credentials, and then they're authorized to client app to make changes on their behalf. This is, for example, I have a preview of how this authorization window can look like. In terms of development, as I said, this comes with Keycloak, so it sort of works out of the box. And we also want to offer the support for command line scripts. And in terms of security, it has an additional layer by using Pixie. With this solution, we can actually go ahead by the middle of this year and offer it to the solution to use. So I'm going to go a little bit more detail about this one. So in terms of how it actually works, you have the end user that initiates the process and they visit a client app. That app needs to develop by you. And if they're not logged into this app, then they will need to go to the authorization server of the RIPE-NCC, and then click on the button, as I showed earlier, where they have to log in with the RIPE-NCC access account. They will add their username, the password, and go through the 2FA process, and then they will have to give consent for the client app to perform their actions. Of course, if they deny, then this flow will stop. So after they give their consent, the authorization server checks if the authorization went well, and then a two-way interaction starts between the client application and the authorization server. An authorization code is sent back and forth, some Pixie secrets are exchanged, and if everything is found secure by Keycloak, the authorization server will return an access token and a refresh token that can be stored in the application. And I'm going to explain more about these tokens in a minute. So when an access token is expired, by using the refresh token stored in the client application, you can request for a new access token. And if you do have a valid access token, what that means is that you can call any of the RIPEDB API endpoints, provide the access token and HTTP header, and then you'll get a response for this. So with OAuth, there are two main types of token. The first one, which is default, is the access token. This is a short-lived credential that grants access to protected resources. It's sent with each API request, and the proposed lifetime for us is 1 hour. Then we also want to enable a refresh token. So it's also called an offline token, and it's a long-lived credential that is used pretty much to get another access token. This is stored in a safe location instead, and it's in the client application that I explained earlier in the architecture. And the proposed lifetime of this is 365 days. And also this matches the API keys lifetime. When it comes to the expiration time of these tokens, there is no standards. It's always a trade-off between security and usability. If there's a short expiry, that's high security. So pros can be that a stolen token can only be used for a short period of time. And then the cons is that, well, if there's more tokens, then there's more network traffic to generate those access tokens. On the other hand, if there's a long expiry, it's better for the users because they are logged in for an extended period of time, reducing the risk of disruptions. But again, that comes with a cost, because if a token is stolen, then it can be used longer and it's harder to detect that it's stolen. So we would like your input on to still gather requirements and see if this solution would work for you, not just the authorization code flow, but an OAuth solution altogether. We are currently looking for volunteers for the first flow, because that's almost ready to go and we would like some testers, so please get in touch with us. But we still want feedback for the rest of the authorization flows. So please get in touch with us. We're also doing some demos this week, so you can book a demo here in Lisbon. So we can show you a client app, like a dummy client app that we've created and how that can work. Or from next week, we can do this online. You can scan the URL and book a slot. So yes, any questions or comments?
So as usual, if you want to ask a question or make a comment to the microphones, please come up. We have 2 microphones in each of the hallways, and state your name and affiliation. I see everyone rushing. It sounds like it was very clear and everyone understood perfectly. Thank you.
Thank you very much.
Hello, everyone. I'm going to go through the NWI review real quick. So as you may remember, last year during the summer, we started reviewing the existing NWIs that we had. There was a discussion around NWI 2 and NWI 17. Both of those were on historical data within the RIPE database. Unfortunately, as you may have noticed, there was no progress made on this. So what I'll be doing is next week, I'll be going through and summarizing the discussion that we had from last year, bring it up to the working, and then bring that to the working group next week or the week after, so we can hopefully finish these up and continue the discussion. If you have gone to the database working group webpage on the RIPE NCC, there is a entry on the left-hand side called Action List. This list was last updated 7th of May 2009. I am proposing that we retire it. I will send a link out to the mailing list so you can review. You have until end of Friday next week, so you don't have to check it during the RIPE meeting. But as far as other NWIs that we have not yet discussed, the NWI 15, 16, 17, which I already mentioned, and 18 are from our NWIs created via the database task force recommendations. We would like you to review this in your time, and once we finish with NWI 2 and 17, then we would like to jump onto this together. Potentially, we will be combining the discussion around NWI 15 and NWI 18. 15 is baseline requirements for registration information, and NWI 18 is operational content information, since these are somewhat related. Does anyone have any comments they want to make on any of the existing NWIs or any NWIs you would like to create within the near future? Sounds like everyone's pretty happy, which we love to see. And we are zooming through. Is there any other business people would like to cover or discuss? Oh, yes, thank you. Yes, Randy Bush has sent an email to the mailing list publishing end-site prefix lengths. This is work being done in the IETF. Right now, there is a draft that exists. You can, Randy thankfully sent a link to the draft that's being worked on. We are quite comfortable recommending to Ed and the database team, please participate in the IETF process and follow this. There are some minor changes to database attributes that are requested as part of this, and then implement those once there is consensus in the IETF list. Is the working group comfortable with this? Everyone like it? Looks like everyone agrees. So thank you. David, William, do you have any other things that I'm forgetting?
So if Randy wants to talk about his proposed NWI a little bit, we still have a lot of time in the agenda.
And we see Randy coming up, so please go ahead.
Randy Bush, IIJ Anarchist. I thought I had escaped there for a minute. How many people here remember GeoFeed? Ooh, that's interesting. So let me back up. Providers of CAPTCHAs, you know, the web thingy that says, "Are you a human?" where you get to educate their AI on what a bicycle is. And people who are sending content like video streams, etc., who want to know if this user is an abuser or legitimate. So the reputation issue can be tied to address space. And if I'm attributing reputation to an address, is that just that 32 or 128? Or is it the prefix? And how long is that prefix? So as a provider, I would like to tell that video site that, hey, I slice up my network by /24s in every city, right? Or whatever the width is. So what is proposed here is like the GeoFeed hack, where the RPSL, the INET num or INET6 num, points to a file which lists the address ranges and the prefix length I am using in that address range. So, and then there's a tool, you know, you don't want the video stream provider hammering the RIPE database for every access. So there's a tool which the video provider or whoever can use that goes and gets the bulk JSON and the RDAP or the FTP, if you're still doing that, and provides the video provider a bulk summary of the data for the entire, all 5 regions, etc. So what this is doing to the database is essentially adding an attribute called prefix len which points, has an HTTPS link to a file. And that file is description of the address ranges and prefix lengths. And if you want to see it in, we've already done this with the geofeed attribute. So if you want to understand the hack, go to geofeed in the RIPE Whois documentation. My friend Rudiger wants to adjust my attitude.
No, question, and where is the document? Well, okay, for geofeed, we have the syntax definition and semantic definition in an RFC, if I'm right.
There's an internet draft for prefix length.
Okay.
Yeah, there's a draft on the IETF mailing list right now. Randy, which working group at the IETF is it? Do you remember?
Not fair asking me questions. The ops area working group.
Ops area, okay, great. And also,
And it's
I believe,
been accepted, and we're just in the final stages. It's actually.
and there's a link to the.
Well, you just
to
go
the
to
data tracker.
Go to data tracker and say prefix length. But if you want, I can post it to the DB list.
I believe you already did earlier this week. I do have one question, and I don't know if it's in scope to this progress proposal or not. But do you also include how many CGNAT users may be
Yes,
maybe
the
behind?
CG. There's a section
Cool.
on CGNet.
Cool, excellent.
Yeah, it's
So I know
pain.
that's been difficult to communicate.
Yes, pain in the butt.
All right. Thank you very much. Okay, so David, please go ahead.
So we've got a little bit of an organizational announcement. This is William's last term as a database co-chair. So Peter and I will be continuing as a two co-chair team. And as a little bit of a thank you for 17 RIPE meetings or 8.5 years of database chairing, I've got a couple nice things for you. I walked around this entire conference asking basically everybody for some nice words and some little things of appreciation for you.
So when I joined the database working group, we had had a lot of turmoil that was on the mailing list. We had a lot of other things that were sort of going on. And at the time, we had a policy that said when you choose chairs, if there were more than the number of seats available, they drew them out of a hat. This was something that we changed very quickly after that. But at the time, the Piotr, who's currently on the board, was the only chair that had any experience. And he was not the one that got selected out of the hat. And so the rest of us have been sort of figuring things out over the last better part of a decade. And I think we've accomplished a lot of great things. We were just talking about GeoFeed and a few other things. That was NWI 13 for those that were paying attention. And we've accomplished a lot. And I think that, Peter and David are definitely well equipped to be better off than we were when we started. But thank you, everyone. And it's not an end, but a beginning. So thank you.
Okay, and before we finish up, there's a few announcements I'd like to make. The NomCom will hold office hours during the second half of all lunch breaks from 13:15 until 1400 the local time. Combined Rue Casania, which I believe is upstairs where lunch is, and you go go through the glass doors and follow the noise. Speak in person to the committee if you would like to. Additionally, you can share feedback on ICP2 from 1330 to 1400 at the meet and greet desk right out here. The RIPE PC election voting will close at 1700 local time today. Please remember to vote. you only need a RIPE-NCC access account, which is free and does not require membership. Speaking of which, if you are a member, please remember to vote in the GM. Additionally, PTNOG will have a feedback meeting in the side room over there from 12:30 to 1300. We would like to thank, of course, Ed from NCC and Adonis from the NCC for their presentations and their work on the database. I would like to thank Hans and for being the scribe, and Tees for the chat monitor. Of course, I'd like to thank the tech team and stenographers. And we'd like to thank you for attending the database working group here at RIPE 90, and we look forward to seeing you next year.
Good day. A routing working group session will start in around 1 minute. Please find a way to your seats. Thank you. Good day again. Routing working group session is starting, and here on stage, us three fine co-chairs, Sebastian, Ben, and me, Ignas. And let's start from a few administrative announcements and matters. First, the minutes of a previous working group session, they have been approved, reviewed by the community, hopefully, and archived. Then another important aspect, and this is seriously important, please rate the talks. This is a feedback channel that we are using for doing post-meeting analysis, and also helps guiding of what you as a community liked and what you didn't like. Therefore, this is important. Please do that. It's not difficult. You need to log in with your credentials into the archive and provide the feedback there. Please do.
Yeah, and another thing ahead of time, obviously, while we love Lisbon and where we're in right now, the program committee, or our program committee, the routing working group, program committee is a different thing. Would really love you to submit our slides, your upcoming talks, which we would love to review as soon as possible, because every single working group ends up with this massive crunch at the last moment, which we don't like, and I'm sure you don't like either. So if you have an idea, just let us know. Even if you don't have slides, please just let us know. We would love to see you at RIPE 91 and have your talk, but we would love as much notice as possible on that. So please rate the talks and please send your new talks in as soon as possible. I think that's it, isn't it? We can go straight.
And there's one other message that we received as a letter from the NCC. It's about the program committee elections. Anyone has got a letter, or it disappeared? Just to prove that we really received the letter. Yes. So there's a program committee elections going on, and you can vote until 5 p.m. today. Please do. And again, this is serious. Please seriously consider who gets elected to the program committee, because that group eventually controls quite a lot of the content that gets onto the agenda. That is important. So with this, let's move to our content part of the meeting. And I'm happy to invite the first speaker, Tim from RIPE NCC, talking about what's going on with RPKI functionality.
Better not. I think I need a clicker.
Bad habits are difficult to get mine. Yeah.
No worries, no worries. Okay. Hello, everyone. My name is Tim Bruijnzeels. I am a principal engineer RPKI at RIPE NCC. I've been doing RPKI for a long time. So some of you will have seen me before. I also see some new faces here, which is nice. Today, I'd like to talk to you about the features that we're working on at RIPE NCC and RPKI. Of course, we do also do other stuff, like we work on infrastructure and all that stuff. But today, I really want to focus on the visible features to you. So I'll start by talking a bit about what we have done so far this year, and then I'll move to the big things that we plan to work on soon. So what have we done? As you may recall, we did a big overhaul of the RPKI dashboard last year. It's been revamped. We like it a lot. We're getting feedback from users. Ed showed earlier in the database working group that we have a feedback form. If you see that, to be brutally honest, when I get the question to give feedback, I usually say no thanks, but it does really help us. So if you would, please. By and large, feedback is very positive. We have had some specific feedback that we were able to incorporate and make small changes. Other than that, we've been working on ROA history in particular. So history is, we keep history of all the changes in your RPKI CA. This has always been there, but it may have been a bit more difficult to find in the past. So now it's more prominently featured on the landing page. And until recently, the history with regards to ROAs was actually text-based. So it's not that easy to parse. One of the things we worked on is to make that more readable, as shown here. We've also introduced filters, so you can just look at your ROA changes and not everything else. We've also just deployed a rollback feature. So this allows you to go find a change that you've done in the past and say, actually, I want to revert to the state of configuration just before this change. Now, if you do that, then we don't just change things immediately, but instead, you get to review your changes. So now, in this example, in our test environment, we don't actually have matching BGP announcements. But if we do, in your case, then what we would show you is this is the change set to go back to that earlier. I tend to think of this as a bit of change management or Git or something. Other things, a fairly small feature in terms of complexity of implementation, but hopefully very useful, is that we've always had these alerts that when we see a change in the routing information that we get from RIS as compared to your ROAS, then we would send you daily or weekly emails if you opt into it, informing you about not found or invalid announcements. Now, what we've added now as well is that you can opt into getting emails when ROA configurations are changed. This is opt-in because we also have people using API and potentially making a lot of changes. So if we would make this the default, then we were a bit afraid that we would, spam you a lot, which we didn't want to do without your consent. So if this is something you like, then you can go into the configuration dashboard and enable this. Now, switching topics a bit. So next things. So I'll go from talking about user UX, essentially, into a bit of routing security. So BGPsec the standards have been around for quite a while. BGPsec is about verifiable paths in BGP. How does this work? Well, a complete explanation of how BGPsec works would take much longer than I have today. So I'll just do the very quick overview here. Hope that's okay. But if there are questions, then sure, bring them up. BGPsec is about signed paths. So it is a way to detect lies in the paths, essentially. Path spoofing would be tamper evident. And the way this works in the RPKI is that in the RPKI, you would create a router certificate that associates the AS number of your router, or your AS number, with a key used in your router. Then the router can sign and validate announcements and updates. There are some challenges around deploying BGPsec. Performance is one of them, and Ignos did some work on this in the past. There's some concerns around downgrades, because if you have incremental deployment, how do you know what should be BGPsec? How do you know what is okay to not be BGPsec? And fail closed is, well, what if there's an issue with RPKI itself? BGPsec path can only be valid or invalid. It cannot be not found. So in that case, everything would become invalid. And I'm not saying that these challenges cannot be resolved, but they have been part of the reason why we didn't enable or support signing router certificates earlier. On the other hand, it's a chicken and egg problem, right? So we have had the request to do this in the past. The signing side of this is actually relatively easy. So we figured, well, you know, maybe we should do the right thing and stop postponing it. So support signing this in the API only. UI can come later when this takes off. But at least this can then help implementers to get the standards moving forward. So next thing is a completely different take on this, which has been discussed in the ITF recently over the last 5 years, more or less, I think. Different approach. So AS provider attestations, or ASPA. This is all about plausible paths. So it's not about having verifiable signed paths and routers doing signing and validation. It's a slightly different approach, as I'll show. So, okay, maybe this is a bit detailed. But if we look at the ASPA objects, it's actually very similar to how a ROA object is built up. So essentially, we have an RPKI signed object that has an intermediate EE certificate. That's just all the plumbing that is needed to make validation work. The essential takeaway here is that as a holder of an AS number, you can make a signed statement that says, my AS, as customer AS, can have these provider AS numbers after me in the BGP path. And, well, the RPKI software takes care of the rest, essentially. But that's what you need to think about. How do we then use that? Well, as I said, ASPA is about having plausible paths, or if we turn it around, it's maybe about having not implausible paths. What I mean by that is that it actually supports the state where you have no no information, you have no attestation, right? So something that is not provider would be wrong, would be implausible. So if we look at the path and we look from each AS to AS hop, we can have a number of situations, right? We can have the next AS listed as provider, which is good. We could have a statement from the AS that about who their providers are, but the next one is not their provider, or there could be no attestation, as I just said. In bullet points here, I explain what maybe is better seen here graphically. If we think about validating routes received from customers, so imagine you're a provider, or in this case, AS1 is a provider, and yeah, I didn't use documentation AS numbers here because they didn't fit. So no offense meant against AS5 here, whoever it may be. But yeah, so AS1 receives routes from customers, right? So on the one hand, we have AS4 to 2 to 1, and all is good. But we have a evil AS5 here who's prepending the path. So they put AS4 in front of them and announce a prefix that's actually okay if you look at the ROA. How can ASPA help? Well, if AS4 in this case made an attestation, made a statement about who their providers are, and AS5 is not in that list, then AS1 can detect fairly easily here that this was not okay. Now, in this case, I talk about AS5 being evil, but maybe a more real-world case can be that, well, you know, these people have a peering relationship and there was a leak. So AS5 actually leaks this announcement upwards to AS3, and they shouldn't have. So in terms of validation, it's the same thing. So maybe let me highlight how I try to denote validation in this case, actually. If we look at the full path here, of 4 through 5 to 3 to 1, then the ASPA hop from 4 to 5 would be considered invalid, because in this case, I denoted as AS4, so that AS2 is in my list of providers, AS5 is not. The other path here, 421, is okay because there are no ASPA objects that say otherwise. Now, if we take this up a notch and then think about how do you do this actually across providers, so routes that you've learned from providers, then things become a bit more complicated. You need to wrap your head around doing this in a slightly different way. And the concept that ASPA uses for this is up ramps and down ramps. So essentially, we can think of these as customer to provider links going upwards to a common point. So in this case, we have here on my left, also your left, I guess, because, yeah. We have an announcement going up from this stop network to the provider, to tier 1. And on the other side, it kind of goes down. I mean, the path continues, but we have another up path coming from the other side. Well, up ramp, you should call it. That we then tend to think of as a down ramp. It's a reverse up ramp, essentially. And in terms of the verification algorithm, what the challenge is that, well, we can look at the full path and we can look at it from both ends. So we try to create the longest possible plausible up ramp that is still does not have not provider in it. We can do the same from the other side. And then we can have a number of situations. So we can have an overlap, typically when there's not enough information. That's okay. We can have them meet at a single point, a common provider, for example, a tier 1 transit or a common provider between stop networks, or they can meet at a peer pair. And then we have one hop that appears to be invalid. It's invalid in case we have a separation of more than one hop. And I'll go through this by example. So here's the example of peers. So in this case, everybody's doing ROAS and ASPA. So we have the path 6325, and all these ASMs have made declarations, and it's all good. Well, the path is good. But if we do the analysis, then 6 to 3 is okay. 3 to 2, that's where the up ramp stops, because 2 is not a provider of 3, 1 is a provider of 3. From the other side, we go 5, 2 is okay. 2 to 3 is actually not okay, because 1 is their provider, 3 is not. But this is where they meet at a pair. And this is a feature. I mean, it might be counterintuitive that you would say something being invalid in the middle is okay. But then, you know, think about internet exchange points and having a lot of peers. And if you had to explicitly name each and every one of them all the time, then this could be quite error prone, right? So this helps with that case. Now, partial deployment, like I said, if you have no other information, then things are okay. So in this case, the AS6 and AS3 are not creating ASPA objects, and the up ramp is longer. And that's okay, they meet. And if you have even fewer, almost no deployment, then you can have a situation where the full path seems okay from both ends, and there's a complete overlap. So this is okay. That's a feature because we want to have incremental deployment. Now, suppose that AS7 here is actually evil, and they start spoofing. So they prepend AS6 and do a more specific announcement, actually, in this case, at 24. And now if you look at the full path, well, AS5 said that AS2 is their provider, but otherwise we don't have any other information. So if you look from the other side, 6, 7, 4, 1, well, you can read it. It's all okay. And from the other side, it's also all okay. So the hijack succeeds. Then you might think, well, what if AS6 just signs ASPA? Then we should be good, right? Well, no, unfortunately, not yet, but we're getting there. So in this case, 6 says, AS3 is my provider, 7 is not. So that's clear. But now if we do the analysis, the up path stops very quickly. But the down ramp looked at from the other side. Now, in this picture, we're inclined to see like this is clearly wrong, but that's because, you know, I drew the arrows and I calls one a provider and a tier one and so forth. But if you don't have the information in ASPA, then you cannot draw this conclusion, right? So there were no other attestations. It could be that 2 is a provider of 5, 1 is a provider of 2, 4 is a provider of 1, and so forth. So that's why in this case, it's still accepted. But as we have even more deployment, this changes. So for example, if this tier 1 in this picture decides to sign an ASPA object that essentially says, I have no providers, because they say, I have one provider, it's AS0, and AS0 cannot legally appear. So essentially that means I have no providers. Now, if you start doing the up and down ramp analysis, the down ramp, so seen from from 5 in this case, stops at 1, and we have separation, and therefore this is invalid. Now, you might say, well, that's okay. 7 can just, prepend with 3 and then 6, and then we're okay, right? And yes. But if 3 also deploys ASPA, then this becomes more and more difficult. So it doesn't protect straight away against all forms, but especially with more and more deployment, it becomes harder and harder to make plausible paths. That, or spoof plausible paths, I should say. Okay, that's all on the way that the verification algorithm actually works. Now, what about the deployment model? The flow of information in the deployment is actually really the same as what we have for ROAS. So you have an RPKI, so the RPKI dashboard, where you create ASPA objects. They're published into a repository, they're fetched and validated by RPKI validators, and then there's a protocol that communicates this information into your router. The router essentially gets a table, doesn't have to do any crypto, but can use this table to do the analysis that we just talked about. If we look at the standards in the IETF, then I think discussion on almost all these things has been resolved by now. There was some remaining discussion about the last hop here about the sort of protocol between the RPKI validator and getting the information into the router, but that's being resolved right now as well. So that's good. We're moving forward. If you look at current implementations, and if you know of others that I've left out here, then please let me know. On the signing side, this has been implemented in Krill. So if you run a delegated CA on an RAR, then you can already use this today. At RIPE-NCC, we have an implementation in our public test environment. There was an email sent about this about a year ago. I want to make sure that we put this information on our website and give it more prominence. We hadn't done so far because of the ongoing discussions in the IETF, but I think the time is right that we do so now. On the validation side, we have support at least in Routernator and in RPKI clients, maybe others, but I don't think so. Routers, well, in software routers, so in OpenBGPD and in BIRD, we have support for it, and I have learned recently that Cisco is actually also working on an implementation. And they might actually reach out to people if anybody wants to test with them. So what I agreed with them is that after this presentation, I will also send a link to this to the mailing list for the people that missed it, and they can respond to this and say, okay, if you want to test with us, then contact us. I'll leave that part to them. So there is movement. What do we concretely want to do as a next step? Well, we want to work on extending the support in the user interface. What we'll do in this case is, just like with the API, we'll use a feature flag, so meaning that we use the same code in our test environment and in production, but to begin with, it will only be available in the test environment. Once we've reached the point that we believe this is feature complete, and we're confident enough that things won't change anymore in the IETF, then we can enable this in production. We're currently working out the ideas of how the UI should look like. So Antonella sitting there, waiting. I'm here. If you have any questions or ideas or are just curious about how we might do this, then you can talk to us. We'd be happy to get your feedback, but also we'd be happy to have your contact and contact you later as we're working on this going forward. Oh yeah, and Aaron and Epinic are also planning to work at least on supporting this in test environments. I think that brings me almost to the end. So I have one more slide. This is mainly for reference. So if you want to read the ASPA verification draft that's in the IETF, or can I mention you, Alexander? Talk to Alexander, who knows more about this than I do, then please do. There's also examples that are being used for implementation testing. And there's a formal proof. Now, formal proofs I find very difficult to read, but you know, maybe you feel differently, and you'd be very welcome to have a read, of course. And with that, I get to the end, and would like to open the floor for questions and comments.
Hello, Gus Kaplan, representing myself. I just wanted to comment on the compatibility. RTR-PR was released last week with ASPA support in both the output and the JSON input and all of the places you would expect it to be.
Nice, good.
Maria, developer of Bird. I'm one of the reasons why that thing is still in the IETF draft stage, because we got in some serious discussions about the wording of the validation procedure. So if there is anybody who would like to read the validation procedure and say something about that, please reach out to me or Alexander. And sorry, Alexander, I owe you an email on this. So please look at it. There should be more eyes than just me, Alex, and Sriram. Thank you.
Vladislav Vodopian from Live. I have a question. How this validation would work in a scenario when an autonomous system is connected to an IX and peers via the road server, so not via upstream provider, but directly. And some of peers announce the prefixes learned from IX to their downstreams. And these downstreams sometimes announce this to their downstreams. Would this be considered invalid if these autonomous systems are not listed as upstream providers?
So I think in this case, do you have a non-transparent route server in this case? Is that what you mean? They would appear to be a provider, right? No, can you? Okay. I'll let the experts take this one.
Okay, so there are two options. First one, if it says transparent internet exchange point, you are merely peering with other members of these internet exchange point, and so the peering is just works fine with the algo, so nothing happens. If it's not transparent internet exchange point, you should add autonomous system of this internet exchange point into your ASPA record to work to make it work correctly. So the document says, if you're not sure that your internet exchange point is transparent or not, just add autonomous system of the route server in the ASPA record.
I'm talking about a scenario when the peer from this exchange point announces the prefixes learned from exchange point to their downstream.
Yeah, I got it. So it should work fine if you follow the recommendations from the document. If you're still unsure, please catch up me after the section. We'll just have a paper and I will show you how it works.
Okay, thank you.
Ignas Bogdanas, FinTech Industry, and speaking as a participant this time. So could you talk a little bit about comparing the ASPA and BGP-SEC? What in fact does that mean for both the community and the industry? Is that a replacement or how should that evolve?
Well, they do different things. With BGP-SEC, you get certainty that nothing was changed in the path by any speaker in the path. But you can still have leaks because it doesn't say anything about whether this path was, well, correct in terms of policy, let's say. Whereas with ASPA, you could have information about policy that can be used to prevent leaks. So in that sense, they complement each other. And it also means that if we do ASPA, that doesn't mean that there's no reason at all to do BGP-SEC. Now, all that being said, and Randy can correct me if I'm wrong, I do think that there is a feeling that as it becomes harder and harder to create plausible paths in spoofing, that may not solve the problem 100%, but it at least addresses some of the problem.
Randy Bush, IJ Anarchist. A significant difference we're missing here is ASPA is path-based, whereas BGP-SEC is prefix-based. And so ASPA could say that this announcement is valid because it was valid for my red routes, but in fact, my blue routes shouldn't be traveling on it, but you will fail to detect that.
Any other questions and comments? Do we have anything online? No? Last call? Well, then, please, a round of applause to Tim. And now we have a logical continuation of the RPKI topics. That's more on the practical side, how to actually implement that, or more the tooling side. And Simon will talk about what he did for diversifying rsync.
Thank you, Ignas, for the introduction, and also thanks, Tim, for the tour de force about what's going on in RPKI. This is maybe a bit light. I'm talking about a specific infrastructure aspect of running RPKI, in particular route origin validation. My name is Simon Leinen. I work for Switch, which is the Swiss Research and Education Network, AS559. We do route origin validation. We also publish ROAs, of course, but I'm not talking about that, although I could take questions. The particular point I'm looking at is rsync as a transport protocol and trying to use alternative applications. So the Go in the title is the Go the language. Could have written Golang, but I thought it was a nice pun. So how does the clicker work? I'm sorry. Advanced, sorry. Yeah, so basically this was supposed to be just a short experience talk, and this is the gist of the message. I try to use this particular alternative rsync implementation called Go Crazy rsync, which is written by Michael Stapelberg, whom some of you might know. And we use that to fetch RPKI material in some of our relying party implementations, namely Routinator and Ford, or we tried it with both. The result is it works. There are some caveats that I go into it, but that seems to be viable, at least with these two implementation. And I'm not claiming that we should go back to rsync in case anybody is insinuating that or starting to misunderstand this. RRDP is great. We love it. But yeah, for now, let's assume we also still have to support rsync. We can entertain that discussion. Also, there are some footnotes. Michael Stapelberg, he did all the work for this talk. He made some changes to his program to get to the state. Thank you, Michael. Also thanks for Ignas and Tim, who sat through a rehearsal of the talk and gave great feedback. Yeah. So why do we think about diversity? I hope many of you here are in the same boat and are doing ROV and are running maybe their own relying parties. And the way we do it, we run intentionally run two diverse implementations. We used to use Routinator and Octo RPKI, and then we replaced Octo RPKI with RPKI client. So that's what we're using in production. There's also Ford, which we are not using, have not been using so far. The reasons why we have diverse implementations, they might be extended to implementations of like the library infrastructure, such as rsync in the system as well. So that is my weak argument for even looking at this. And again, the assumption is that rsync can just be switched off tomorrow or something. So we had a look at alternatives to the rsync implementation that we, and I think many people have been using, which I think is the Tridge, the original rsync coded by Andrew Tridgell of Samba fame. Many people also use Open BSC rsync or Open rsync. I don't think we do. We use whatever comes with Debian. But those two are written in C and fairly widely used. But there are others, and the particular one I'll be looking at is called Go Crazy rsync. And it was written from scratch. It was written from the paper, I think, that specifies rsync that Andrew Tridgell published long ago. I think it has been involved somehow. They are now they're at version 27 of the protocol, or they're at version 31, but he implemented version 27. I'm not 100% sure. So Michael Stapelberg, he may be known to some of you because he also wrote he must like Go. He works for Google in Zurich, and he also wrote his complete home router implementation in Go. All the user space in Go is on this called Router 7. Might be interesting to you, and I think the rsync work comes from that space. So that's what I'll be talking about. There are other implementations. I have not looked at them. That's for sure. Many people have tried to rewrite it in Rust, but I don't know, maybe for future study for others. So why consider Go to implement something like rsync? One reason is memory safe. I know there have been debates how valuable that really is as a feature. I have no personal experience with Go. I have lots of experience with other memory safe languages like Lisp and yeah, I know Perl, Python, and have written. I think that there is a point that it's actually more safe if you don't have to worry about freeing stuff and writing beyond vector array boundaries, like in C. So, but of course, people have been doing good work in languages without that feature. But maybe the impetus for looking at this at all, I don't know whether you remember in January this year, there were some vulnerabilities reported against the common rsync implementation that had fairly high risk scores, and some of us have been scrambling to upgrade. And these issues were related to exactly such like buffer overflow, like things that are hard to reproduce in a language like Go. So I think there's some empirical basis for the suggestion to move to memory safe languages. Also, Go has a nice features for making use of multiple threads, and today all computers are very multi-threaded, so it's potential for improvements, performance improvements, and so on. There are other reasons too. It has a modern library ecosystem that makes it maybe easier to write safe programs handling files and so on, but I not go into them further. So why this particular Go Crazy implementation? I think there are other Go implementations, but for me, that one was attractive because the author had been working with large systems and is also seems to be a known person in the Go community and has been publishing like stuff. So it's not just you know, recreational programming kind of thing. But most importantly, when I reached out about the idea, he was very open to helping me or the community, both by with like normal support and also by implementing missing features, and he has done quite a bit of that. So thanks again. Also, we used to both live in Zurich, since then I moved to another part of the country. So for me, that was an argument, because if he's doing too much work, then I could easily buy him a beer or something. So what's the status of compatibility? I didn't manage or recently try to make it work with RPKI client, because RPKI client makes quite some hardwired assumptions about command line options that must be present in the RPKI client, that are of course present in open BSD rsync. I'm sorry, rsync client, not RPKI client. And when I started trying that, many of them were missing from Go Crazy. But Routinator, or other production implementation we use, it could be made to use this alternative system. I had to tell it which command line arguments are safe to use. There's this configuration example there. And later I also discovered Fort, which I hadn't used previously. It can also be configured in a similar way to be compatible with Go Crazy. So it's not a one-to-one plugin replacement yet, but you can make it work in this context for sure. And then I got it all running on test servers, and then I wanted to know whether it also produces reasonable results, because at some point I got no more error messages, but well, it's maybe not enough to be to trust it. So, and I did this like this week from the hotel, of course. So I set up 2 Debian VMs in our VM infrastructure, installed the same recent version of Fort, and then I selected. That is what makes Fort interesting for this test. You can select priorities for both RRDP and rsync. So you can tell, okay, try to use rsync wherever available. And only if that doesn't work, then you can try RRDP. So this is like a safe configuration that will exercise rsync a lot. This is a bit harder to do that with Routinator. So I set this up. I started with an empty cache. I let it run. And I looked at what happened. So starting with an empty cache, the system, like I guess all relying parties have to do this, will go and collect, starting from the trust anchor lists, start to collect this RPKI material from everywhere. And then once it has done that, then it starts being able validating. It validates the data, and then it will become available for routers to use that information. And it logs when it has done that, because it's happy. And then subsequently, it will, like periodically, I think with Fort, it's about once an hour or so, it will go again through the tail and update the information that it has retrieved if it changes on the repos. So here are the results. I hope you can read them. There are 2 columns of numbers. The left column are the results for the standard canonical rsync, and the right column are the results for Go Crazy rsync. And you see that it takes, with the alternative Go Crazy implementation, it takes quite a bit longer this first run to collect the data. So that seems unfortunate. But you also see on this third row of numbers, after this initial run, the Go Crazy system that uses Go Crazy rsync, it ends up with 5,000 more validated ROAs. This is just like 1%, but it seemed to be repeatable. Okay, so this is from one run, but I didn't trust my eyes at first, so I ran that a couple of times. The results were very similar. So that could be worrying. Maybe yeah, you think it's getting some stuff that is not really, that shouldn't be there. That would be bad. But I thought about this and I come to the conclusion that it's just more patient. So it picks up stuff that takes too long for the old rsync. The old rsync will give up while the new one is still trying to get the information. So the reason why I think this is that if you wait, if you leave both systems run for a while, then so subsequent runs, which don't have to transfer everything, just what has changed, just check what has changed and transfer the delta. They are very similar in speed, no clear winner, but the number of validated ROAs with traditional rsync, it converges to what Go Crazy rsync gave me on the first round. So that's reassuring. It's, I guess we don't get much extra stuff. We do get a little extra stuff in terms of files. I looked at that. For example, there are files called something.aspa, which with a traditional sync, they aren't transferred because they are intentionally excluded, and the new rsync, it doesn't support the exclusion option yet, so it just transfers them. But I don't think that hurts a lot. So that's performance-wise, my conclusion would be, okay, so this doesn't take 10 times longer. It's very similar in performance. It seems to get the right data, highly unscientific measurements. I hope there are not too many, or if there are measurement research people listening, this is not how you should do measurements, but it's like what an operator does when they want to know whether anything works. So looking towards the future, what could we do? Maybe implement those missing options. I think include and exclude would be potentially valuable to, I don't think they're that vital because there's not much other stuff right now than what we're interested in, mostly ROV, but it could be good. One thing that I noticed, I found out that the original rsync has is it, unlike many utilities that when they're done, they either terminate with a 0 exit code, which means everything was fine, or with a single error exit code, like 1 or so. Rsync, the Tridge original rsync has a lot of different exit codes, meaning different things, like I couldn't reach the server, or I was able to talk to the server, but then it timed out or something. And Go Crazy rsync does not have that. It's just 0 or 1. And actually, there are some relying party implementations that expose these error codes in like Prometheus metrics, so you can make Grafana dashboards from them. So this is a little piece of functionality that you lose when you replace traditional rsync with Go Crazy rsync. Maybe it could be implemented also. Another possibility was if you are considering using or writing a Go-based relying party implementation, which I don't think exists anymore. Octo RPKI was one, but that seems to have gone. Then you could easily integrate that as a library. As for other relying party implementations in other languages, it's may not be attractive to use a Go library. I'm not sure. Yeah, the big question is why do we waste time with it? I mentioned I like RDP. There has been a lot of discussion why rsync is not good enough. Before this week, I was actually more defensive or more worried about that argument. In any way, my thinking was even if we manage to deprecate rsync use with RPKI, which some people have tried doing, but it's a bit hard to to mandate this. We'll have to live with it for a couple of years. Since then, I actually heard some arguments why it would be good to continue having it, for example, as to use rsync as a fallback protocol in cases where RDP doesn't work or has problems, or so maybe I'm even less negative about that. Yeah, so, and the general moral thing here is, yeah, this is clearly the old thing, but we as a community, I think we have been quite good at keeping the old stuff. Maybe IPv4 is a bad example, but maybe it's like running despite new sexier things coming up, and this might not be where the money is, or don't work on these kinds of things if you want to be the next whatever or make a career. But it's part of the gardening, the chores that we have to do to keep this thing running, right? And of course, the actual reason was that I was interested in Go, and I thought, yeah, maybe this would be a good opportunity for me to get my feet wet a little bit and do some coding in Go. And then when I run into issues, I can always ask this pro to fix it. But of course, as things go, Michael did all the coding work, and I still wait for an opportunity to learn some Golang. Yeah, that's it. Thanks. I hope you find some of this relevant and have some question. Thanks a lot.
Yeah, Tim Bruijnzeels, RPKI. Yeah, I have well, thank you for doing this research. I think it's good to have diversity in rsync clients. I was one of the people who at some point tried to really deprecate rsync, but the message back from the IETF is that prefer RDP is okay, but we really want a fallback protocol. So the while might be quite long that we need it. And on that, well, we actually need to run an rsync server, and diversity in server implementations would also be very helpful. Do you know if there's an effort to make this into server?
Yeah, so honestly, I didn't think about that before this week, but because we only validate and we outsource all the publication to RIPE NCC, who have been doing a great job. But thinking about it, I think Go Crazy rsync will be probably even more useful on the server side, on the publishing side, because I think there are quite a few thoughts that Michael had about doing this securely and making use of restrictive mechanisms and safe library calls specifically for the server side, so that you can reduce the risk, the attack service on that side. So yeah, I encourage people to look at this, but as I said, we don't publish, we let you publish. So, but I think that will be potentially even more useful. Thanks.
Hi, Ben from BGP Tools, speaking for myself, not the working group. Something that is worth keeping in mind with the lack of include-excludes thing is a bit of a problem, because if somebody accidentally puts like a, I don't know, 5 GB ISO file of Windows 11 on their rsync endpoint by mistake, a lot of people's VMs don't have enough disk space, and without those flags, it will sync it down. So, I mean, in theory, also, of course, people could put a 4 GB X509 certificate, but that's slightly less unlikely, slightly. So it is a good, it's not a foolproof mitigation, but it definitely helps solve the really silly mistakes.
Yeah, thanks. This is a good point.
Also,
I have certainly not done any like security testing. I know there's also another option called max bytes or something, or max size.
Yeah.
That maybe supporter might be more effective against that case, because like you can also just call the file .roa or something, and then will be transferred.
Yeah.
But yeah, it's a good point.
And I think also to a previous comment, I think OpenRSync, it does have a server backend that you can use, which I think was one of the major motivations of writing it.
Yeah, I'm sure OpenRSync has many well thought out security features, and I just don't know it that intimately. But yeah.
Randy Bruce, IJ anarchist. Ben, don't let Windows on your machine.
I haven't tried it on Windows, but it should work.
Ignas Bogdanas, FinTech Industry, speaking as a participant. Actually, a question about tool versus library. So now you have developed an equivalent of a tool. What would you think of developing a library instead? Well, in one of, say, particular language of choice, like C++, and defining bindings to other languages of less popular choices or more popular choices, instead of maintaining basically separate tools, maintaining a lower number of libraries that can get reused. What's your opinion?
Yes, so there are aspects related to this Go implementation. I'm sure the author has library use in mind, but then I also think that this might not be helpful for people wanting to use other languages as Go. So I think you're more alluding to focusing work on writing library in a traditional language, right? Like, or a language that interfaces more easily with other runtime systems like C, C++, maybe Rust. That is a fair argument, and I don't want to attract people to contributing to this Go implementation or Go ecosystem without thinking first whether it will be better for the community to invest that effort into like maintaining quality implementations in more conventional languages that interface with other systems more easily. Does it answer your question?
Not that I was expecting a definitive answer to that. So this is something that is much more into the software engineering aspects and overall systems engineering than just a particular tool. But specifically, there are languages that are easier to interface with for the reasons that they have stable ABI, and some of them don't and probably don't plan to. Certainly can be done. The question is at what cost and at what complexity.
Yeah, absolutely. It's an important kind of consideration. I think from what I know as an outsider, I think the Go community has been quite conscious and has done a relatively good job of keeping compatibility across, at least across versions. So this stable interfaces consideration, I think that's very much part of the Golang mindset. It's my impression. But yeah, if you try to go outside of that language ecosystem, so in Java you have the VM and you can mix languages easily. I don't know, use a Scala library with a Kotlin program or something. That's not Go, but otherwise, I think for versioning I would place some trust in Go as a platform. But I have very weak opinions on Go. I'm not an expert by any stretch.
Excellent, thank you.
Thank you.
Any other questions? Do we have anything online? No? All right, last call for questions. No questions, then a round of applause.
Thank you.
And now we're moving to a slightly different talks. Don't be surprised seeing Alexander on stage, because he will not be talking about ASPA. He will be talking about something very different, but that's just a different aspect of networking.
Hello, everybody. So it's routing working group. And so I will not speaking about BGP. I will not be speaking about RPKI. And I will not be speaking about routing incidents. And let's talk about load balancing. And in this report, I will present results of our research about is it feasible to build a stateless layer 4 load balancer. Okay, you are all network engineers, but imagine that you have backends. Normally, it's a kind of HTTP service. and you need to balance ingress traffic toward these backends. How to do it? Of course, you can just have a rack, directly plug in these backends to the top of rack switch, and you will have equal cost multipath, and it will work. It will balance traffic, but will it scale? Unfortunately, it will not be scaling beyond the rack or beyond the radix of the switch or beyond the size of equal cost multipath group. So lots of limitations that really doesn't meet requirements of applications that has a significant traffic volume. So usually, the high-level design of a system that processes HTTP requests look like this one. So there is a network, there is equal cost multipath that balance traffic for layer 4 load balancers. And layer 4 load balancers performs kind of magic. We will go deep inside this magic during this report and deliver traffic to the backends. So how layer 4 load balancer works? It depends on the implementation, but normally it advertises what is received via DNS. When you type fqdn in your browser, you are receiving A or quad A records. And so layer 4 load balancers are advertising these prefixes into your network. And when this traffic is received, it's maybe knotted, maybe encapsulated, as I shown on this picture, and so it's a layer 4 load balancer chooses to select a backend to send traffic for a specific TCP connection or UDP connection. It doesn't really matter. So it's why it's layer 4. It works not only with the IP header, normally it also works with TCP or UDP headers. And what is quite important is that the response from the backends goes directly to the end user. So the traffic is asymmetric. And the reason for this asymmetry is cutting the cost, because normally the volume of traffic that your backends are sending back to the world can be much higher than the volume of traffic that they're getting from the world. But what if one of the backends fails? It's the responsibility of a layer 4 load balancer to detect it and to change its balancing policy so that the traffic is rescheduled to the backends that are still alive. It uses hash tables to select the backends and to load balance traffic between them. And in a simpler situation, it uses, for example, a hash function, and after that it divides the results by the modular of the number of the backends. And so, as you can see on this example, on the left side, there is a map of keys and backends when we had 3 servers, 3 backends, and on the right side when we have 4 backends. And as you can see, the result is that there is a significant change in this map. And I believe it's not the expectation of the end users, it's not the expectation of the application developers that if one backend goes offline, every TCP session is resetted. So we need, if we started sending traffic to a selected backend for a selected TCP session, we should keep sending traffic. And this gives us a problem. Not a problem, but it makes our system stateful. Let's see how it works. When we receive a SYN packet, we are selecting a backend according to our current hash table, and we are adding it into connections state table. And when we are receiving an ACK packet, we're checking this table. And if there is a match, we're sending traffic to the selected backend. If there is no match, we are just dropping packets. But there is a question, maybe a question, how we delete connections from the connection table, from our contract. We do see only half of the packets. We do see only ingress flow. And there is no other way than to see maybe resets, but because fin packet is not enough, or to have a timeout. So if a session is not active for a selected period of time, we can believe that our garbage collector system can remove it from table and everything should be fine. So what we've learned. So commonly, layer 4 load balancers are working only with ingress traffic. They perform active health checks. It may be TCP-based, it may be HTTP-based, it may be some specific protocol-based, but so it's active health checks. And it's stateful. And it's vulnerable to DDoS attacks. Let's get back to one of the previous slides, when we have a high-level design of our system. And let's imagine that there is a SYN flood that is attacking one of our services. And so what we are expecting that layer 3 switches are just invulnerable to DDoS attack. At the end, let's say we have a Linux or something like this, we have SYN cookies, so that they are kind of protecting us against SYN flood on the server side. And we have layer 4 load balancers that can't protect themselves in any way. So the result may be that the contract table is growing. It's growing fast. You have a collision. After you are facing collisions, you are facing first service degradation, and after that you may have experienced a full denial of service. And this problem is not a new one. There was a lot of paperwork in the academia that was trying to find a way how we can remove states from the layer 4 load balancers. Commonly, you can cluster them in two main options. First one, let's offload the states to the network. For example, okay, we will use maybe Server 6, maybe other tunnel technology that will try to reroute traffic between backends. So when a backend is receiving traffic that is not supposed to be in its, not supposed to be locally so if there is no local active contract table, so it is rerouted to another backend. Another approach is to use TCP to offload data about the chosen backend. So it's some space in the TCP options, and you can put a key or something, some identifier of the backend into this option field, but there is a problem. So in both cases, both scenarios require a real hard integration between your application and end users, or your application and the network. So to be realistic, the solutions that require integration between your application and end users, the browsers, they just don't work. If the requirement is just integration with your network, it may work, but you may also have some issues, and it will be really hard to deploy it in production. So the question was, is it possible to get rid of states, but will not with no requirement to support it at the end user level or at the network? Let's take a little takeaway. Let's speak about consistent hashing. Previously, we talked about that rehashing can dramatically change the map between the keys and the backends. Consistent hashing is a set of different mathematician methods that provides a way to hash it in a way that the fraction of changes corresponds with the fraction of changing backends. For example, if you have a 100 backends and only one of them flaps, it will not affect the full hash ring, but it will be affecting only a small fraction of it, or maybe in ideal situation 1% of the table. Here is an example how it works on a hash ring of size 10. It was a real implementation on Python, I believe. And so as you can see, so it's just the same example. We added one backend, and the hash ring has changed, but not that much as it was when we were just using division by model. Is it enough to get rid of states? Unfortunately, it is not, because still there is changes in the tables, in the key maps, and we want to keep all TCP connections that were previously established to be established. We don't want them to be reset. And the problem still is that when the set of backends changes, it changes the hash. So we don't know how it was changed. And this is kind of a dead end until we change the rules. What if instead of when we make a rehash, we don't drop and replace the old hash ring, but we keep them all together? We have old hash ring and new hash ring. And we can, and if we do it, we can see which keys are stable and which keys are unstable. Do we need states for stable keys? No, we don't, because it was working, selecting same backend when we were using the old hash, and it's using the same backend when we are using the new hash. With unstable parties, it's more difficult. Let's see how it works. In case of a sync packet, first we need to check, is the hash stable? If it's stable, we just following regular procedure, we just instantly encapsulate packet and don't create any states. If it is not stable, we create a state and again encapsulate a packet. With egg packet, it is a bit more difficult. First, what we are doing, we are checking if the state exists. If the state exists, we know the selected backend, and so we send the traffic. Second, if the hash ring is stable. If it is stable, once again, we don't need a state. We know that previously we were sending traffic for a selected backend, and we can keep sending traffic to this backend. And if it is not stable, we can guess that we were using the old hash to send traffic to the backend, and we are creating a state and sending traffic to using the old hash. It's very important to understand how to perform so we have, when the set of backends is changing, we have a situation when we have two hash rings. And at some point of time, we would like to merge it. And because when we are merging them, we are getting back to the full stable system when we don't need states at all. And so if there are continuous changes of the set of the backends, we don't create the third hash ring, the fourth hash ring. We are only replacing the candidate hash ring. And if there are no further updates for the timeout that is equal to the timeout of the session, we can guarantee that all sessions that were previously established were mapped to the proper hash ring. We created states if it was needed, and we can merge them and get one hash again. So it is nice theory, and we decided to check it in not in our lab at least. And we needed an implementation of a consistent hash ring. We needed implementation of layer 4 load balancer. And at the moment when we were making this research, it proved out that choice was to use IPv6 with implementation of maglev hash that was published a few years ago by Google. And so we took this piece of open source software and implemented off top of maglev hash stateless. And here's how it works. In this scenario, we were just performing a lot of frequent requests to our backends, and also we did some instability of this backend. So there was a number of flaps, and we were measuring how the fraction of flaps affects the system. As you can see, so if in our case there are no flaps, there are 0 states, because the hash ring is stable, and we don't keep tracking on any TCP states in the system. If there is a 10% of flaps, still it's by order of magnitude is we need less states than the vanilla system. And more importantly, it's quite important in terms of CPU usage. It reduces the CPU levels by nearly 4 times. And of course, for the classic maglev implementation, so it's not affected by the instability. It always keeps states, always performs lookups in the into this growing table. And in our case, yes, it was quite effective. So what we learned, it's possible to create a nearly stateless layer 4 load balancer. It significantly reduces both the number of states in the contract table and reduces CPU usage in our implementation on top of IPv6. And most importantly, this approach doesn't require any kind of integration with your network or with the end users. And our prototype is open sourced. You can follow the link, see it at the GitHub, and if by chance you are still using IPv6 in your environment, you can try it. Thank you for listening.
Hi, Christopher Jumba of Deutsche Telekom. Have you compared it to, for example, the GitHub GLB implementation or Cloudflare Unimog that uses a second chance hop instead of keeping state at the load balancer level?
So it's so what we've seen from the what was attempts of doing it in industry. So we took a look to what was doing from the GitHub team. So all of them required the integration from the backends. And this is the main difference here. So comparing performance is kind of irrelevant because you should compare performance of the same basic system. So the approach itself, it's you can implement it on any kind of layer 4 load balancer. The only requirement you need an implementation of consistent hashing. And so to speak fully open, in our environment, this project was kind of unlucky.
Okay.
The reason was that when we started this project, there was also a parallel activity and ongoing project to switch the environment of our layer 4 load balancers to a new system built on top of DPDK. with a much higher performance. And the system is called Yango. It's also open source, but without this model of double hashing. And I hope that this year it will be finally open sourced with this model too.
Okay, thank you.
Ramon Bister from the Eastern Switzerland University of Applied Sciences. I'm just wondering, like comparing with application layer load balancers, which would typically be used in production to resolve this issue of failing TCP connection or resetting TCP connection if a backend fails, because the connection is obviously terminated there and set up a new one. Would this stateless layer 4 load balancer be an advantage compared to application layer load balancer that you can, for example, guarantee like that end-to-end encryption between client systems?
Normally, let's go back to the high-level design picture. Normally, in a huge environment, when you have complicated applications, these backends is what you are calling application load balancers itself. So the question is how to balance traffic that is coming into your network between application load balancers.
Okay.
So it's part of their system, and there is no conflict of interest. They are just working together.
Okay, yeah, perfect. That clarifies it. Thank you.
Hi, Maynard Koch, speaking for myself. I read the README and read it to the end. They say that, well, hash tables, as you know, are unsorted, and you do sort, well, the patch sorts the hash table, and they use linear sort for insertion. So I guess the performance may be impacted in case if the hash table is really large. Have you done any testing with significant number of connections? I don't know, thousands, millions?
So as you can see, what we were testing, it was about 250,000 simultaneous connections for each second.
Right. So that was not a problem in practice.
No, no problem. So we were it was quite an interesting project. I really loved working on it. And yes, the precautions of checking the stability of the hashing is just working.
Okay, thanks.
Right, any other questions? Do we have anything online? No. Last call. Well, no more questions then. Applause for Alexander once again.
Thank you.
And this brings the content of our meeting to the end. What's remaining? Again, important message. Think about, if you are thinking about submitting something for RIPE 91, do that earlier than later. If you want to discuss whether you should submit, you can find chairs and discuss. And another one is the PC elections. So that's a message that we have received. You still have an hour or an hour and a half. So cast your vote. That is important. With this, the meeting comes to the end.
We're finishing a little bit early, so you have plenty of time to log into the RIPE portal and rate the talks, which I would really appreciate.
Indeed, yes, do it. And this is important. This is a feedback channel for us, and this has influence in what content you will eventually see in the other meetings. Thank you.
Hello, everyone. Please come in, find a seat. We are already 2 minutes in. We have a packed agenda. I would like to start. Just to a few announcements at the beginning. The PC elections, the elections for the RIPE Program Committee will close today at 5 o'clock. Which is, so you still have an hour. It's always like after the community plenaries are making the announcement before, so you still have some time to vote. The link is on the main website of the RIPE 90 in the meeting pages, so you can find it there. And I'm also going to make a few more announcements now, because otherwise I might forget at the end. We've actually found an Apple Watch already earlier this week. If you miss one, it's at the registration desk. You can pick it up there. I think they already found it on Monday. Maybe that person has left right now, I'm not sure. And then I have very sad news, is that tomorrow morning, there won't be a barista. I know. I was like, oh, I'm dreading making this announcement. You're going to rip my head off. Because there was some miscommunication with the supplier. Unfortunately, they won't be available tomorrow morning. There is a cafe around the corner. I think if you come out of the hotel to the left, Workplace Cafe, they're open in the morning. And the good news is we only start at 9:30, so you have a bit of time to try to find a coffee elsewhere. And of course, there will be coffee break, and hotel coffee will be available as well. It's just that so stack up on barista this evening if you still need them, because they're not here tomorrow. And then for the RIPE dinner tonight, for those of you who have tickets for the RIPE dinner, their buses they will be leaving the hotel here at the entrance at 7:20 and 7:30, so 7:20 and 7:30, and they will return every 30 minutes starting from 10:30 to 1 o'clock. That's the last bus. So that was all the announcements from my side. I hope to see many of you at the dinner tonight. And then let's start with the program, with the agenda. We have a packed agenda, so I'll give you a quick update from the RIPE chair team. Neil is here. I saw him coming in. Where are you? Oh, there you are, the vice chair. Then we'll have a report from Hervé, Clément, the chair of the NRO Numbers Council, to wrap up the feedback that they received during the week here on the new OER governance document. There will be a short update from the RIPE nominating committee, where they are with the nominating process for the next RIPE chair team. And then there will be actually a technical talk amongst all these administrative updates about the next generation of BGP collection platforms. Thomas Holtenbach is going to present that. I think you're here. I hope you're here, Thomas. So hope you'll be there then. And then at the end, we'll have a quick presentation by Philip Oldham, the RIPE NCC Web Services Manager, about the new and exciting new RIPE meeting website that you can expect. And then hopefully, maybe we'll have some time for AOB and open mic at the end. So I'm going to speed up. Just a few updates from our side, what we've been doing since last time. I mean, you can, if you follow our updates on RIPE Labs, we try to keep you up to date of what we're working on and where we're hanging out, what kind of events we're attending, and what we're focusing on. And since last time, we've published the document, the RIPE document that we've all been working on, and we declared consensus earlier on the relationship between RIPE, the document that describes the relationship between RIPE and the RIPE NCC. So that's been published as RIPE 838. Then we've also been working together with the RIPE NCC, mostly the policy officer, to review the whole policy portfolio. And if you were at the ADOS policy working group, you heard Angela talk about this. There are so many policy documents. Are there some, maybe they can be consolidated? There's some low-hanging fruit where we can start making it easier for people to find the right information in the whole policy forest that we have in this region. And so we continue to work with her on this, and there might be a little task force formed to help her. We also continue to work, look at the RIPE document store. It's kind of a bit of my hobby project to make sure things are consistent in there. We have consistent metadata. We know which documents are public and up to date, and which ones are what's the word? Not archived, outdated, whatever, obsolete, I think is the term we're using. Thank you. And to make sure that, we can find things properly in the document store in it, because that's really our bread and butter, our production, if you will, our output of this for this community is our documents. We've also continued, of course, to promote VIBE specifically to newcomers. You have heard maybe in the a diversity session earlier this week, we're reviewing the whole mentorship and fellowship program together with the VIBE NCC and also with the community, obviously, with the mentors. We want to beef that up a bit, make sure it's easier to find on the, when you register for the website, if you need a mentor or if you want to become a mentor and help newcomers and mentees. Also, the VIBE NCC this time, we didn't have an online student session, but instead the VIBE NCC actually visited some universities here in Portugal before the meeting and promoted the VIBE community and the fact that we're coming to town here. And I think it was quite successful. I believe some of those students were actually at the meeting. And you see the lovely picture of the some of the fellows and the Resi fellows that are here during this meeting. And then also, we're also participating in various meetings around, to not represent, but to make sure, we know what's going on in the ITF, and, we're at the regional meetings and various network operators group meetings. Neil's attended some exchange point meetings also. I'm going to go to the IK meeting, IGF, just to make sure we know what's going on and to update you about it as well. I'll be coming back quickly to ongoing policy discussions. There are 3 policies currently. I just want to make sure you're all aware of this. There are currently 3 policies in the address policy working group. All of them are still in the discussion phase, so you can still participate, provide feedback. What's not on the slide because there wasn't, it's not actually published yet. There is also an initiative in the routing working group. There was a discussion about the non-functional, delegated RPKI MCA. So there's an initiative to clean that up by Job Snijders, and that will turn into a policy proposal fairly soon, I think. So that's also ongoing. And then also community activities, obviously, the policy discussions are also communities. They're not like made by Neil or myself. There was a discussion also in the diversity session, helping the VIBE NCC events team to make sure we have all the accessibility. We have a good view on accessibility issues, and it was decided this time that maybe setting up a team or advisory group was a bit too heavy-handed. But we're going to work maybe on a checklist and help the VIBE NCC to make sure we have. We are aware of various accessibility issues that people might have, and so we can inform you before each meeting what if there are any issues at the venue. VIBE NomCom will have their own presentation, so that's still ongoing, and the same for ICP2 and the RR draft document. They were going to present about that. And then just one thing I want to mention is above. I want to mention this because the BOF today is kind of a follow-up of the BOF of the task force that produced a recommendations document for DNS resolver operators, and this one is going to look at authoritative name servers and possibly having a BCP about that as well. And that's about it. Just a pointer here to our updates, our monthly updates that Neil and I provide for you on the VIBE Labs platform, if you want to follow what we're up to, and also you can of course provide us feedback and add comments and questions. Yeah, that was that. Are there any questions, comments? Is there anything online, Pedro? I think you're keeping an eye on that. Nope, nothing online. All right. Well, then, in that case, I would like to ask the next speaker, Hervé Clément, to give us an update or wrap up all the feedback that you've heard during the week about this document.
Thank you, Mirjam. And good afternoon, everyone. So one more time us, one more time me this week about this very known ICP2 So be sure it won't be another presentation of the ICP, what it is, etc., etc. So we know. But we will report the different outputs we heard about you from the community during the BOF and during the policy working group as well, and to collect that in an efficient way and very quickly. We had the support from the RIPE NCC staff, and specifically Ulka with there to help to prepare this presentation. Quick recap of what happened in terms of presentation and information we shared about ICP2. It's an ongoing consultation for the communities of the region and for the ICANN on this consultation of this draft, which is called now, but it's not a definitive name, Real Governance Document, opened the 14th of April and will close on Tuesday, the 20th of May, so the next Tuesday and not this Tuesday. So I learn in English, but this and next is not the same. There was a RIPE NCC open house on 29th April. Probably a few or some of you have attended that. There were also both this week on Monday, and it was organized to hear your feedback, and it was very interesting feedback. We also, as I said, presented the document during the policy working group because there is the ESOAC report generally during the policy working group. It was yesterday. And so what are we doing there? Again, so to present the outputs of what you said. What we heard during this meeting, RIPE 90. There was feedback on the language, on the tone of the document that was produced. There were concerns about the level of detail and implementation as well, and larger philosophical approach to this topic. Many remarks and many, to be honest, very interesting remarks, and I will go in further detail about that. About the document structure and language. So you had some ideas and remarks. The document we have produced so far needs to have goals. And if you see the frame of the document, it reads more like a contract. And it's not apparently very homogeneous, because it varies between high-level principle and mechanics at a more operational level. So it's a thing probably to balance about that. The language in the document could be inconsistent. You have must, you have should, and could be perhaps on short-lived, soft term, and some parts should be more precise. For example, the term of geographic area, which seems to be a little vague. The prescriptive tone contradicts the community-driven nature of the regional interregistries. When you see the document, it's like to be, as we say, very prescriptive, apparently, which is not finally the nature of the community. But for this aspect, decision-making concerns, because in the document there are a decision to do regarding recognition or derecognition. The opinions on unanimity are not unanimous. So we have to take it into account. Several of you suggested using majority-based model, so instead of unanimity. The current model assumes good faith by all parties, and this assumption of acting in good faith is being questioned currently. And there needs to be clear clarity on decision-making criteria. For example, which criteria should apply to each decision point, and that's something more that is not very clear. There are different regions, so there were questions about the applicability of the document across region also. There are currently, and there will be, of course, regional differences, or the regions are not the same, and we need to consider a basic set of features that are common to all registries, but only a basic set, or to be recognized as a registry. And there was recently discussion, for example, of whether a natural person can be a member. Apparently, I say apparently, but it's a fact, that there are differences. One more time, prescriptive, sorry. The prescriptive language could lead to a casual reader to assume that there are new obligations being imposed from outside the regional bottom-up community-driven process. Okay, if you read the document, because we have not all the same culture, the same business, the same profession, and if this impression is given, there is something to do to smooth that. Challenging to reconcile the historic view of the community grounding with the language of the document. It could be the same problematic. Perhaps the document is a too legal form or something. The implementation with all the decisions that are dealt with the document, business continuity plans are important, and details like escrow are less so. And also, in case of the recognition and modification, how would an handover one regional registry to another, from one regional internet registry to another, work? For example, whose policies will apply? How will policy differences be addressed? Who will actually take charge of that? So there are some elements which were questioned. What are the decision-making thresholds? How will we gauge support? How is impact measured? That are a lot of aspects, details or not detailed, that are to be considered also. Finally, that were specific points and specific family of points dealt with you on the big picture regarding the comments. Finally, the document needs to reflect and safeguard the value of the regional internet registry communities, the stability, the stewardship, the fairness community, the bottom-up aspect. They must be inclusive and representative, and we think it's important as well. The role and relationship between the regional internet registry, the NRO, and the ICANN needs to be clarified also. And we have to be clear about what that we want from this document. And one more time, thank you for all your remarks. We were particularly impressed by all these remarks, the interesting remark, the useful one, and is the fact that is a document that is most interest for you, and you have read it very carefully. So one more time, thank you. What next? We will take your feedback to the NROEC, because here we are only Constance and Andrei for the RIPE NCC service region, and Nicole from the APNIC also, but we are 12 currently. We will, as we did for the last consultation, summarize, cluster, and categorize the feedback, and the NROEC, the SOAC, will meet during the next ICANN 83 will take place in Prague between 9 and 12 June, which is the next month. We will discuss the feedback, we will discuss your concern, and we will work on the second draft from that. And the aim is to share the second draft ahead of the regional internet registry meetings in the latter half of the year. It was no timeline you perfectly know, on Peter share it also. We are still on the stage of the public comment of the draft. You have still the link to the specific draft, if by chance few of you have not read it. And guidance for the feedbacks as you will have. So if you answer, and so if you give feedback, please share feedback that is specific to this draft and not for anything else. And we are particularly interested in hearing your views on the new requirements in the draft, because there are new things, of course. Whether the draft provides sufficient clarity regarding the ongoing obligation of a regional internet registry and the remediation steps if the obligations are not met. So we want your view about this whether. This document doesn't address the implementation of the regional internet registry criteria. Comments on implementation will be considered out of scope. That's so to give one of the goals. And of course, we appreciate constructive comments. The consultation will close next Thursday, 27th. Then that's a summary on what I said regarding the next steps afterwards. Just to say before, yeah, in Q4 2025, there will be a final review and revision of the updated document, and it will be the start of the NRO and the ICANN approval and adoption process. And with that, one more time, I thank you, you too.
Thank you, Hervé. Are there any questions? As we have a few minutes. I see one here.
Yes. Hi, Hervé. Remco Vermoek speaking on a very personal title. Another 24 hours. Thank you, first of all, to you and the NRONC for embarking on this large and thankless project. It is a huge body of work. You're giving it your all, and it's very highly appreciated. I have one concern, which is we're writing a lovely new document. We have a lot of new important things in there, which all should be in there. But we're not doing a greenfield. This is where we have an existing environment where this document will have to end up in. And with my personal hat very firmly pulled over my ears, a thing called fiduciary duty comes in. And that particularly relates to topics of consensus between RIRs and, things like that. And it is very important for the community and the work you realize in the further documentation that we need to end up with a document that the boards of the RIRs, which is where this will end up, will be able to sign off on in line with their fiduciary duties as board members of those organizations. And that's what I'd like to comment. Thank you.
Thank you. Well noted.
I don't see any other questions, comments, anything out. There's one there.
Okay. Lohan Larus Limited, and obviously I like to make comments and to be noticed comments of number portability as well as the recognition of the member rights, which is very, very important to the continued existence of the IR system. As my not so top, as Alex noted, right, the law firm has noted the potential antitrust investigation into the RIPE's monopoly behavior and abuse of member rights. That is not a situation to be in, and that is not a situation to need to be in, because RIPE can simply get out of it by recognize the member rights officially. The rights of the members are mostly already recognized through various policy documents as well as a corporate document of RIPE anyway. And we just need to make them contractual, and it's be great that such enforcement of member rights, such as IP ownership or rights to the registration or number portability, being recognized in the ICP2 for the next 20 years of the IR system stability. Because the current model, which the IR holds absolute power and ownership to the database, while the databases already have over $200 billion in the market value, is just dangerous and unprepared for when it was first designed 20 years ago. So I urge the ASOEC to take a serious consideration and looking from all perspectives, not just in the perspective of, there is accreditation and a decreditation problem because WOM's IR happened to lose its board, but take it from a much serious point of view and adopts the governance change for the next 25 years ahead. And the problems I've highlighted in writing in the RIPE list and that antitrust matter should be taken seriously into this ICPG revision. That is my feedback. And I've specifically said in the content of it, well, it is related specifically to RIPE NCC because that's the IR operated in this region and under the European law. But this is also feedback to the ICP too, and please take note of it. Thank you very much.
Thank you. I don't mention portability because it was not mentioned during the both and during the policy working group, but I know it was mentioned in another fora. It's not a problematic, and we do take it to account seriously every topic. Thank you.
Thank you.
Thank you. I just want to, just to clarify, maybe this is, I just want to close the mics. Thank you for your comment. And it's more, we had a feedback session, we had a BOF session, and there's still feedback till the 27th of May. We don't really have a lot of time to engage here and discuss this again, but I'll accept those two questions, of course, that are still at the mic.
Tobias Siewich, Max Planck Institute for Informatics. Speaking for myself, I would like to remind the room that this discussion we have about value placed in databases stems from an artificial shortage of IPv4 resources. This whole discussion and this whole stress could be alleviated by just migrating to IPv6 already. So please. So please, everyone do that, and keep in mind that anyone in good faith wanting to make this world a better place in this context will ask for an IPv6 flag day and not for any other approach to solving this problem. Thank you.
And thank you for your remark.
Pedro Vaz, RPNCC. I have a question on chat from Nurani Nimpuno from Links. Hi, my question is not directed at the ASOAC, but to the RPNCC and the other RIRs. So right now, Ephenix is under a receivership, and they have put all their IP allocation on hold, which means that no new members can get IP resources in Africa. That's a rather grave situation. Are the RIRs doing anything to try to solve this blockage and finding other ways of providing RS services to African networks? Is there a workaround in motion, or can anything be done to provide African networks with addresses during this time?
So I will perhaps leave the answer.
Yeah, I don't think we can answer this right now. They will note that and then pass it on to the RPNCC to consider. Thank you. Okay. Thanks, Hervé.
Thank you, Mirjam.
Right, next up on stage, thanks again for this update. This is great. And I think this really gave a good summary of what people raised during the BOF and during the week. So thanks for preparing that summary. Next up is Jan George, the chair of the RIPE Nominating Committee 2025. Is it not nominating committee? Anyway, go on.
Hello, I'm Jan George, the chair of the NOMCOM, and would like to give you a brief update with how things are going. So, as you may be aware of, the RIPE community will choose its next chair and the vice chair by the way of a nominating committee. That is a group of people that is basically randomly selected from a pool. And here at this point, I would like to mention that there was feedback from the community about the diversity of the NOMCOM, of the voting members. I would like to remind you that we asked for volunteers. We got 52 volunteers in the list. That was not very diverse from the start. And then there is a random selection mechanism that the randomness is actually selected by 3 different lotteries on a specific date that we put in and reorder the list of the volunteers. So it's completely random. We got this feedback, and I would like to remind you that this is completely random process, and by random it was selected non very diversibly. Going forward, there's 10 people that are voting members, and we have some non-voting liaisons and advisors that forms the NOMCOM. So the liaisons are from the working group collective, from the program committee. Then we have liaison from the board that is actually observer of the validity if we follow the process correctly, and the advisor, that is actually the previous NOMCOM chair. So these are the nominees for the RIPE chair. This is Fergus and Mirjam. Then we have for the vice chair, we have 3 nominees, Olena Kushnir, Anna Wilson, and Rob Evans. The order is by the timeline when they were nominated. So it's how they were nominated in time. Hallways, this is the important place for the discussion. All the NOMCOM members are in Lisbon here. You're welcome to chat to us in the hallways. We didn't have the special badge, so we just wrote NOMCOM on our badge. So if you have any feedback or suggestion and you see the NOMCOM person going around, please talk to us. And we are around majority of the time. We have office hours on the first floor. We have a room, the office. This is next to the children daycare. And we have the open office hours from 1:15 to 2 every day. So today, yeah, it's already gone, but tomorrow we will still be there. And if you have any feedback, suggestion, please stop by, come in and have a chat with us. Confidentiality. If you come to our office, we usually close the door, and whatever is said in that room is confidential. We treat it confidentially, and it needs to be confidential from both parts, from us and from you if you walk that office. This is how our office looks like from the hot chair perspective. We are trying to make it as accommodating as possible, and we have coffee. Okay, so far we got a lot of feedback directly during the open office hours. There were people coming in, and also the nominees came to talk to the NOMCOM. And thank you all for providing feedback. It is very, very useful for the whole process because we need to understand what the community thinks. Due to high demand during open office hours, we limited the time per visitor to 10 minutes. And again, please talk to us. Tomorrow we'll be there during the lunchtime. And this, if you want to read more, and there are already published minutes from the first and second official meeting of the NOMCOM. They are on the ripenomcom.org, or you can send us an email. And with that, are there any possible questions? Oh, Brian. Well, that's the template. It is what it is. I tried to fix it.
It's abstract art.
Yeah. Keynote.
Brian Nisbet, HEAnet. So I think half blaming the community for the lack of diversity of the NOMCOM is similar to blaming users for clicking the wrong link on systems we badly designed. I think that what we didn't do the last time, I understand why not, we didn't really kind of review and look at the process. And I think what we need to do as a community, and whomever the right people to commit, and I am happy to volunteer to work on this, is to make sure we don't get to 5 years down the road when we say, oh, we started this process again and we haven't changed it. And I think there are absolutely ways in which a process can be designed which can support a diverse NOMCOM, which I think is absolutely vital. So I'm willing to volunteer to help work on that as well, but I think we just need to commit as a community that we will do that.
So, yeah. So one way of doing this is there will be a NOMCOM report with the suggestions and advice for the next NOMCOM, and this can create a community discussion, because fundamentally this needs to be changed in a policy, in a process. But yeah, I think we need to work on that.
Thank you.
Leo Vagoda. Someone approached me earlier on and asked about voting in the non-com elections, and I explained the situation. They're fine with it. I think there's been a gap in communication about how the process works, and that might also feed into the lack of diversity in the people who put themselves forward for the non-com. And so I think for the rest of the process, you might want to redouble communication so that you're getting as much feedback as you can from people who can't be here. And you might want to think more carefully about the communication process for when we do this again next time.
Okay. Well, we had the extensive explanation last time in Prague and at the opening plenary, but yeah, thank you. Daniel?
Yeah, I'm not in the blame game, but I got that feedback also, like why this undiverse nomcom, and also like where do I put myself forward? So I think that there's some truth to what Leo says. On the other hand, if I cannot let that stand as it is, because as Shryane has said, there has been extensive communication over the last few meetings on how this works. There's a blog. We communicated ourselves silly, and we also canvassed for volunteers. Especially when we saw the first 30 or so come in very undiverse. I personally went out and asked many people to increase the diversity of the group. And frankly, the willingness of people to come forward for this work was less than stellar. And then afterwards being blamed for this, I take very personally. Thank you.
Neil O'Reilly. Not quite outgoing RIPE Vice Chair. So not in the sense of this is not my problem, but following up on what Brian had to say, I think it will probably be an early item on the agenda of the new RIPE Chair team. That's what I expect as a member of the community, and what I would also expect if I were in a position to be selected as the Vice Chair again, which I'm not.
Okay. Thank you very much. That's a good suggestion. Don't get me wrong, but the NOMCOM process is it's a lot of work, not just from me and Daniel, but from all the members of the NOMCOM. So before I go, whoever from the NOMCOM is here, can you please stand up so people can see you? So if you have suggestions, talk to these people that are standing right now. And if there are no more questions, this is all from me. Thank you very much.
Thank you, Jan. Thanks for running this process. Next up, we'll have Thomas Holterbach from the University of Strasbourg talking about the next generation of BGP data collection platforms. And they actually have a call to action from the community and want the community to participate. So that's why we felt it was appropriate to have it in the community plenary. Please.
Thank you for the introduction. I hope you... Okay. So yes, this is going to be a technical presentation. I'm going to talk about BGP data collection. So I'm sure many of you know RIPE-RIS, RAW-Views, PCH. Those are BGP data collection platforms, and they are extremely useful for the community. So they collect BGP data and they share it with the community. So we can build monitoring tools like rsync, like BGPlay, and there are even many commercial tools that rely on this data. Yeah, so the routers that share the data with these platforms, they are like our satellites. Each of them which we call also a vantage point, has a partial view over internet routing, and it's when we combine all these routers together that we can have a large view over internet routing. So today, I'm here to introduce you a new BGP data collection platform that is called bgprods.io. We say it's a new platform because we actually just launched our new website 3 days ago. So I cross my finger that everything is going to be okay. And we also say it's a next generation platform because we don't just try to improve the collection of the data, but we try to improve the entire pipeline from collecting the data to storing it and finally to distributing it to the users. And that is what I'm going to show you today. But before I start, you may wonder, why did we decide to implement and build a new BGP data collection platform if there are already RIPE-RIS, RODViews, and PCH that exist, and they seem to work fine. So this is why I would like to start with this percentage today, 1.2%. What is this percentage? This is actually the percentage of ASCs that share their BGP data with RIS and RODViews. We also say this is the coverage, and we were surprised to see that this is a rather low number, especially given that RIS and RODViews, they always try to deploy new vantage points. So we also measure, how this number evolved over time, and we found that actually it did not increase. So it's now like 2 decades that we have only about 1% of the autonomous system that share their data. This is a bit worrisome because, as I said, those routers, those ICs, they are like satellites. Okay, so we need as many of them to be able to see everything in the internet routing. So now, what can we expect in the future here? Can you expect a better coverage? Well, unfortunately, not anytime soon, because RIS and RODViews, they are extremely useful platforms. They are fantastic because they take data and they keep it forever, and it's extremely useful for the community. The problem, though, is that they have to deal with a lot of data. So there is this trade-off between coverage and data management costs. And basically, recently, RIPE-RIS and RODViews, they switch from an open peering policy to a selective peering policy, meaning that they are sacrificing coverage to reduce the data management cost. And this is fine. At some point, they have to take a decision like that. But that might be also an issue regarding coverage. So, of course, you may wonder, perhaps, well, maybe a 1.2 coverage is just fine. Because after all, a BGP router, there is the S-pass, there are the community values. So we can see things a bit remotely, right? So we can see remote path changes, for instance. So perhaps this is actually enough. And that's a good question, which we cannot answer precisely today. Why? Because we just don't have the grand truth. Okay, we don't know what we would see if we had 10%, 20% coverage. What we can say, though, is that it likely depends on the use case. There are some use cases for which just a few vantage points, maybe just one is enough. There are some other use cases for which you need as many vantage points as possible. So what we decided to do at the University of Strasbourg is we wanted to understand more what we are actually missing. So we did simulations. We simulated a mini internet in our server with 6,000 autonomous systems. We configured standard BGP policies. And then we took several use cases and we tried to see what we are actually missing with a 1.2 coverage. So today I don't have the time to go through all the use cases that we did. I'm only going to focus on 2 of them. 2 that are very common is detecting peer-to-peer links and also detecting forged origin hijacks. So our simulations, they say that with a 1.2% coverage, we actually miss 84% of the peer-to-peer links today. If this is true in the reality as well, it's a bit worrisome because it means that all topology, the S-level topologies that we are building, they are likely inaccurate. And for forged origin hijacks, we observed that we are missing 24% of them. So it looks better than for peer-to-peer links, but a hijack is something that is very bad. It can be malicious. It can impact connectivity. So you really don't want to miss a hijack. So it's not so good either. So for more information here, more details about the simulation, for more use cases, I just invite you to read our paper from last year. It has been published at Sitcom. For now, I have to move to the next slides because I don't have a lot of time. Okay, so now is the time. I'm going to introduce you our new platform. And I will explain you how we improve coverage, how we improve storage, and finally, how we better distribute the data to the users. So I'm going to start with the collection. So first of all, BGP routes.io simplifies, automates, and opens BGP data contribution to every autonomous system. So everyone in this room, if you operate a network, you can authenticate using PeeringDB, and then you just have to fill up a very simple form. It takes 2 minutes, and you can start peering with us and sharing the data. We will share the data with the entire community, so it's going to be beneficial for every one of us. However, just doing this, it's not going to be enough to reach like a high coverage, obviously. Besides, we also realized that all the existing platforms, the public ones, so RIPRIS, RoadViews, PCH, we even found like a small platform in Asia, CGTF, which shares the data. Each of these platforms, they have strengths and weaknesses. So for instance, in terms of peering, some of them, they allow physical peering, some others, they allow remote peerings, and they have different peering policies as well. So they all have like strengths and weaknesses. Regarding how they share the data, again, some of them, they have APIs, some of them, they have real-time streams. So now in this table, we could add BGP routes.io. It's a new column here. Again, we have strengths and weaknesses. One of our weaknesses, for instance, if that we don't allow physical peering, we just do remote peering. But it's when we actually realized all of this that we decided that we should not try to compete against those platforms. They're all good. No, instead, we need to embrace all of these platforms. So what we do is we take all the data they collect and we put it into one single repository. Okay, so today, BGP routes.io already stored data for more than 5,000 vantage points. So this is hopefully how we hope to achieve high coverage more quickly. Okay, so now I'm going to explain you how we achieve low data management cost, because in fact now we are collecting a lot of data, so we also need to deal with data management cost. So for this, we actually worked hard during the last 2 years to develop new BGP data compression algorithms. I don't have the time to really go into the details because this is like research work, but in a nutshell, basically we found that there is a lot of redundancy in the data, so we could really optimize things when we store the data. So we have two types of algorithm. We have the one that are lossless and the one that compress the data in a lossy fashion. So if you're interested, for instance, by our lossy compression algorithm, you can read our Sitcom paper from last year, a paper that actually was possible thanks to a RIPE community fund. So thanks a lot, RIPE, for this funding. And for now, what I also want to say is that we're only using the lossless BGP data compression algorithm because we don't have a lot of data yet. We just started the platform. So for now, it's all lossless, but eventually at some point, we will use our lossy compression algorithms. Okay, so finally, I will explain you how now we try to better distribute the data to the users. And for this, we have implemented a fast API, which enables users to retrieve the data with a very high granularity. And actually, this matters because collecting more data is great, but it's not very useful when users, they are not equipped with the tools to effectively process this data. Okay, so perhaps amongst you, there are already people that try to analyze BGP data. So they went into the route views MRT archive, and then they found all those MRT files. There are like thousands of files for reads, dumps, for updates. Those files, they are compressed, and everything in those files is mixed up. So there are things for multiple vantage points, multiple prefixes. So it can be like quite time consuming, and it can take a lot of resources to process all these files. And that can be quite painful when you want to analyze something. So just to illustrate, imagine you are a network operator and you just want to get the BGP updates for which your ISN appear in the ISPath today, okay? And imagine that this yellow space here is all the route views MRT archive. So it's like tens of terabytes of data. Well, if you want to answer this query, you probably just need this green slice of the data. It's just a few kilobytes. The problem, though, is that if you just want to analyze this small slice of the data, you will have to download and compress and analyze a large slice of the data here in red, and that's gigabytes of data. So we actually asked researchers that works on BGP if that was an issue for them, and they said yes, it's actually an issue. They don't have often the time and the resources to process all this data. So what they do usually is they resort to sampling. So they just download less data. They are still downloading gigabytes of data, but less. What does it mean? It means that basically they will in fact analyze some of the slices that here matter for them. So the blue slice here. But it also means that they will not analyze some of the data that is useful for them because of this sampling, right? So they will miss important things. And this is exactly what we want to avoid. So this is why BGP routes.io also comes with a fast API, which provides a very high granularity access to the BGP data. So we have 3 endpoints, vantage points, updates, and RIB. And then each of these endpoints come with many parameters. So you can really build very flexible queries and just get the data you need. So the goal is that you never download irrelevant data anymore. That's the goal we want to achieve. So if you're interested, you can try it out. There is a full documentation on the website. And yeah, you can just try. So just to conclude, I just want to show you how you can use it in practice. So for instance, if we take the query that I was using before as an example, so you want to get all the updates with a particular ASN in the ISPath, you can use a Python client. So you import it. It's BGP routes API. And then first you get the vantage points you want using the vantage point function. So here, for instance, we just take all the vantage points from BGP routes.io and RIS. And then you just iterate over this vantage point. And for each of them, you get the data within the specific time frame that you want. And you can only also get the updates, which include the ISN in the ISPath. And for that, you can use ISPath regular expression. And then you will get just that slice of the data very quickly. Okay, so that concludes my presentation. So thank you very much. So if you want to peer review us again, you can just go on the website. It's super easy. And we will share the data with the community. And now if you have questions, I'm happy to take them.
Hi, hello, Sander from Ventus. I have a question about one of your first key points, the collection and high coverage. I'm curious if you won't end up with the same and comparable VPs that other tools already have.
Sorry, can you say it again?
I'm actually curious about the fact if you won't end up with the same VPs that the other tools already have.
Oh, that is possible. Definitely, it's possible. Actually, RPKI and route views, they are already ASNs that pair with both of them. So it's possible. It might not be completely useless though, because you can have routers in one ASN that see different things. Actually, most of the time, perhaps in 99% of the time, 2 routers in the same AS will see the same things. But here, we still care about the 1% that is different. So this is why we really tell people to come and peer, even if they think that they might be redundant with some other existing VPs. We have algorithms that will automatically find those redundancy and that will eliminate them if using our lossy algorithm, for instance. So you are right, but even if you think that there is like a lot of redundancy, it might still be worth peering with us or with any other platform, actually.
Thank you. That was the second point that I had. Good job and good work on the research that you're doing. Thank you.
Thank you very much.
Antonio Prado, Fiber Telecom. Thanks for your work, for your research. I like it very much. And just a little curiosity from my side. This is a project with a long-term scope, okay, in order to get and to have data available for a long time for research, etc. I went to your website, but I didn't get what kind of funds you use to and the business model of this kind of project.
Yeah. So for now, this is like a research project. So we use like research funding to manage it. Of course, we would like to make this platform sustainable over the long term. So at some point, we will need to find funding in a way or another so that it can stay alive for years, hopefully. And we are working into that. So this is why also we are here. In this conference, I could talk with some people, and thank you for that. It was amazing. So we could gather some feedback and see how we could, in a way or another, make this platform sustainable over the long term. One thing I want to say also is that we are also working hard to reduce also the cost of everything. So hopefully, you know, we try to limit the cost so it can survive over the long term, even maybe through like some research funding or something like this. So we are still investigating all of this, and that's a good question. I don't have a precise answer. We will try to do the best we could. Yeah, for now, that's where we are at this point. Yeah.
Tobias, I think we're next.
Tobias Siewich, Max Planck Institute for Informatics. And I was wondering, you identified the difficulty of looking up, for example, data from route views because it's just so vast of a database and you then want to search through it. Have you thought about ingesting all of that data into your system as well? Because that should be doable given that it's more space efficient.
You mean taking the past data as well?
Yeah.
Yeah. So we could do this. The problem is that inserting, so there is a lot of data that is coming already now in real time. So we are roughly ingesting like 1 gigabytes of data every day. And if you want to take, aside from that, the past data, at some point in terms of the writing speed, it's going to be tough to populate the database in real time, plus taking the past data from route views. It's going to be tough system-wise.
Wait. So you are currently hitting performance issues if you would start to ingest, for example, route views at some reasonable speed, like say factor 20 of real time.
20 times more than what you get now.
Well, 20 times more than the real time ingestion speed of route views was. So that you would basically need like a year, 2 years to ingest the whole route views. That would already not be possible?
So the thing is, perhaps it would be, and in fact, we have algorithms that optimize this. So for now, you just need to keep in mind that we are running this thing on 2 commodity servers with a very tiny funding. And for instance, we have a server that just have a 2 terabytes database, hard drive, sorry. So for now, we would not be able to do this. We don't have the hardware capacity to do this. Now, if one day we can buy more servers, perhaps in fact, we could go into that direction as well and take also the historical data and put it in our database. But for now, we will have too many constraints in terms of the hardware.
Okay, so it would also not be possible to have like a large influx of peers right now.
No, the real-time peers, this is fine because the problem is once you get the historical data, it's a lot of data, right? A lot of more than just getting the real-time data. So For now, I don't think we have the capacity to take real-time data plus all the historical data from route views, for instance. We won't be able to do this now with the hardware that we have.
Okay, thank you.
Yes, Emil Aben, RIPE NCC. I was kind of involved in making the peering policy for this a bit more selective. The eggs to me for that. We did this because not because of the volume, but because we kept getting the same types of peers all of the time. So they were very similar. So it's not the volume was not necessarily well, it was also a problem, but not the main problem. But question is, your simulation, would it actually be able to help us with finding the peers that add diversity to the platform?
Well, that's a good question, but there is, so that's actually what was one of our challenges when we wrote our sitcom paper, is that you are saying that peers are similar, but what is your definition of similarity? And what do you think people will be interested in when they will look at the data? Perhaps they are actually interested by measuring similarity between the vantage points. And that is the challenge, is that there is no today consensus on what is similar, what is not similar, what is redundant, what is not redundant. And this is why when you say, well, 2 vantage points, they seems to be similar, so we just take one of the 2, we don't take the same approach. Because first of all, even if there is just one person that is different, we still think that it can matter for some people. And even if they're redundant, you could still be interested by measuring this. So for instance, perhaps you want to see whether your prefix is visible from everywhere or things like this. So if you see redundant things, it can be useful in that sense. So yeah, that's a tough question. Yeah, so what was the rest of the question?
Can you give us like very practical recommendations on how, for all route collection platforms, on how they can add to their own diversity and maybe the collaborative diversity?
Yeah. So in the sitcom paper that we did, so the approach we tried to use was not to take some use cases and to check whether this vantage point would be better or not. What we decided to do is to do like a sort of a compression, like when you compress images, right? So you want to remove pixels that are not important when you want to reconstruct the original image. And that's what we are doing in our case. So we try to remove the data from the BGP archive, which are not important when you want to reconstruct the original archive. So we are not taking any definition or like, I don't know, if you want to detect hijacks or whatever. We really take this simple definition, which is also used, for instance, in image compression. So we are doing the same thing, but for the BGP data. And our algorithms, by the way, that we published in our sitcom papers, they are online, they are open source, so you could use them and you could check which piece of the data matters or not. And maybe that could help you to decide if you're interested. So that's the way we did it.
Okay, thank you.
Sure.
Thank you again, Thomas.
Thank you
for this presentation and good participation, good questions. Last, yes, thanks. Last up is Philip Oldham from the RIPE NCC. He's going to talk to you about the new RIPE meeting websites, which is relevant for you all coming to the meeting, registering for the meeting, finding stuff, and the clicker. Thomas, did you take the clicker? That happened to many people before.
All right. Hello, everyone. This is going to be a brief on some notable changes we're making to the RIPE meeting websites and what that means for you as attendees. The good news is that there's no action required on your part, not even a routing update. I'll start off with a quick introduction. For those who don't know me, I'm Phil. I'm manager of the Web Services team. Web Services looks after the tech behind the NCC's public-facing websites. So that includes the main RIPE.net website, the lab's blog, and every RIPE meeting website to date, all 90 of them, although the oldest ones live on our shiny new RIPE.net platform. For the past few years, the team has been working on consolidating all of the systems we manage into a single tech stack. And for the last 9 months, our focus has been on developing a single platform to host all future RIPE meeting sites. We're also replacing the well-loved but hard to maintain tool that we use to manage the call for presentation workflow with something called pre-talks, which you may be surprised to learn is not the NAT traversal technique. It's actually a robust open source tool used by many NOGs and tech communities similar to our own. The goal of these changes is to simplify the development process, making it easier for my team to respond to issues, manage changes more effectively, introduce new features, and importantly, reduce the attack surface. Up until this meeting, each meeting has had its own WordPress instance, which required a lot of manual work and, once deployed, attracted a lot of attention from malicious actors. So we're pretty happy to be moving away from that platform, especially since the new setup makes it easier for us to follow accessibility guidelines, which is something we're keen to do and aligns with the NCC's goal of being more open and inclusive. What this means for you, hopefully most attendees won't notice too many changes. We've migrated the existing layout and menu structure, so everything should continue to feel familiar. The move to pre-talks, however, will affect those submitting talks for future meetings. Web Services has been testing pre-talks in parallel for the last 2 meetings, and we've already seen it working pretty well. We're currently wrapping up the final integration pieces, and that's behind the scenes. But as we all know, the real feedback loop only starts when people actually begin to use the system in production. That said, we hope that the track record of pre-talks with other NOGs means fewer surprises for everyone involved. So when is this happening? Right now. The RIPE 91 website is live on the new platform with many usability and accessibility improvements already in place. And the call for presentations using pre-talks will open in a few weeks once the wrap-up of RIPE 90 is complete. In the meantime, we've already had some useful input from the program committee at this meeting, which will add to our list of updates to be implemented in time for RIPE 91 in October. But we'd still love to hear from you, the attendees. These systems are built for you, and your feedback is invaluable to me and my team. If you notice any problems, especially during the talk submission process, please do get in touch using the usual channels. We're happy to help. And that's the brief. Any questions?
No questions? Do we have time? You're looking forward to submitting your talks to the new system. All right, well, okay, thanks again, Philip. That's it. That actually leaves us with a bit of time. So are there any other topics you'd like to bring up? Any questions you have? Any maybe topics for next time?
Oh, my personal message inbox is overflowing. So I'd like to clarify something about what I just said about the diversity on the NomCom thing. My comment was not to what Brian and Leo said, and I'm absolutely in favor of reviewing the way this is done. I was more reacting to the reactions I got from some community members, where I felt I was being personally blamed for say the lack of diversity. And again, I personally approached, and I know other people approached eligible persons to serve on the NOMCOM, and we were turned down a lot of the time. So it's not like they didn't know. Yeah, it's not like a communications problem. It's a problem of the community not willing to take, or good parts of the community not willing to take the work. And we actually increased diversity of the pool, but the randomness just was random and didn't reflect fully the diversity of the pool.
So Tobias Siewich, Max Planck Institute for Informatics, also a member of the current NOMCOM, but in all capacities speaking for myself. I think the most important point to take away is that we hear that there is an issue and that we as a community will revise our approach to the NOMCOM process. And that will likely also be a top agenda item for the incoming chairs for the next NOMCOM process in 5 years from now. And we will strive to do better then, and we have to have a more diverse and representative of this community NOMCOM select our next chairs.
I guess I can use this microphone. Yeah, just to clarify what Jan said earlier also, what the previous NOMCOM did is after this whole process is over, there will be a report with a number of recommendations, probably to how I expected. I mean, that's what happened last time. And then after that, the community can go through the recommendations and can address them and improve the process for next time. So just to clarify the process there. Are there any other topics? Anything else you would like to bring up? If not, I can have a longer coffee break. There's still two BOFs after this session. And after that, again, there will be buses for those of you who would like to attend the dinner to bring you to the venue down the hill, so to speak. And I'll enjoy the dinner and the evening. And tomorrow we will start half an hour later at 9:30.
Test. Okay. Hello, everyone. I'm very happy to see still quite a few people joining this late BOF just before the ripe dinner. Please take a seat. So yeah, you've probably already know that the title of this BOF is Authoritative Name Server Best Practices. My name is Moritz Müller. I'm one of the DNS Working Group co-chairs. I'm working for the Dutch CCTLD registry. And the main goal of today is to share current practices on name server operations. And we hope that these 4 panelists will share with us what works good for them, what does not work, what should be avoided at all times, and mainly learn from each other. And then the secondary goal is to maybe come up with a document that summarizes these best current practices for name server operations in some shape or form. Some of you might remember we have another document, a RIPE 823, that discusses resolver best practices. It has been published last year, and the question would be whether we need maybe such a document in this form or maybe another form as well. The question also remains whether this is whether RIPE is the right venue for that or not, but that is hopefully something that we can discuss as well. So before we go into the topics, I would like to introduce our panelists. I will start with far left from your side. We have Anand Budev. He works for the RIPE NCC now since almost 20 years. I think next year there will be an anniversary. And he's responsible, among others, for operations of KRoot, secondary DNS services, and enum. He also has, I think, his most favorite BCP already in his T-shirt right now, so I think we can indeed include this one in the document already. And he shared his recent work also at the DNS Working Group yesterday. Then we have Doris Hauser. She works at nic.at. Nic.at is the registry for the AT CCTLD. And they also run our Code Zero. It's an Anycast-driven DNS service. She's a Linux sysadmin, mainly with a bit of networking and scripting programming work on a day-to-day basis. And until this meeting, she was also one of my DNS Working Group co-chairs. Then we have Lars-Johan Liemann. He's the co-founder of NetNode. This was in 1969. 96, not that old.
Not quite.
But also an anniversary next year. And he has spent more than 30 years plumbing and tinkering with the DNS. He has many hats on ICANN, also at RIPE. Too many to mention here. NetNode runs one of the root servers as well, and they also run an Anycast service, among others. And then we have Shane Kerr, another former RIPE DNS Working Group co-chair. So now you know where we volunteer our panelists from. He's a DNS software developer at NS1, and he has also been around in the DNS for quite some time, working among others at ISC and Dyn. How we would like to manage this discussion is basically I would like to kick off with one topic here, and after this topic we would like you as the audience to shout out or come to the mic and recommend a topic or suggest a topic that we should ask the panelists for their opinion. This also includes, by the way, the online audience, so feel free to suggest a topic in the chat or with the Q&A function. And this could be topics on the slide, could be any other topics you think is interesting. You might notice that DNSSEC and other zone management related topics are not on there, but if you think this is relevant, then we can definitely also discuss this. And if you feel silly, you can probably make a bingo sheet out of that. And if you have 4 in a row, just scream camel or something like this. And after this discussion, which hopefully take around 40, 45 minutes, we hopefully still have some time to discuss the next steps for this BCP. So without further ado, I would like to kick it off, and I would first ask your opinion on infrastructure. Like, how do you pick your infrastructure for running your name server? Do you prefer virtual services, hardware services? And I guess we'll just start with you, Shane.
Okay, yeah, so we run a pretty standard model that I think most authoritative operators do, which is that we have updates occur in the core and then we push them to our distributed edge. DNS is a super read heavy service, so that's pretty normal and standard. So all of our software is proprietary. We wrote it ourselves. We come from a startup background, so that makes sense from us because venture capitalists want intellectual property. It's not, personally I prefer open source, but that's where we're at. Anyway, so we run our stuff. We did a forklift migration a few years back into AWS. So all of our core runs in AWS. Everything runs in containers there. We use Kubernetes there. We also run Kubernetes we run containers at our edge. We haven't done it in Kubernetes. Kubernetes, as if you worked at it, it's an opinionated provisioning system, which it doesn't seem to have a good opinion about DNS. It's not a it's not a good match. But we just use Docker at our edge as well. We mostly just do transit for our IP connectivity. We do a little bit of peering, but not too much. And so we rely on things like scrubbing services and things like that for DDoS mitigation and things like that. As far as our edge hardware, it's just normal, like just normal PC servers basically for everything. We don't have special fancy, we don't have special routers or anything like that. It's all pretty bog standard hardware. And that's basically it. Yeah.
Okay. Thank you. Any other experience with Docker and DNS?
We don't run Docker systems for our DNS service. So I would like to start off with saying that one of the big features with this is that you can do it in so many ways, and that different ways have different properties, and that's the strength of the system. It actually boils down to the root server system operators have, eventually landed in a motto, which is diversity is good. So you actually strive for diversity between different operators. That's a good thing. In the Netnode case, we own all our hardware and we operate virtual servers on the hardware. We don't use containers inside that. And we have a system of distribution nodes. The things that kind of makes it a little complicated is that we have a lot of zones that we operate, and in order to maintain updates to be efficient, we have this rather complicated system of notifies going across the system to keep up the speed. But we strive to use plain hardware, general off-the-shelf software, preferably open source if we can, and we can in most cases. I cannot really see off the top of my head that we have commercial products for running the systems. We have some commercial products for the provisioning systems behind, but it's typically that we pay for an upgrade from an open source product to something with some extra features that we would like to have. So I think that's our plain overview of what we have. We do operate a large Anycast networks, and in contrast to you, we actually do a lot of routing ourselves. So but we do routing from virtual machines in the same hardware platform, using again open source routing software. And yes, that's a pain to maintain, but that's what we use to keep our platform running. Thanks.
So for nic.at, in terms of infrastructure, we have both virtual like cloud VMs, but also rented bare metal servers and also co-locations where we have sent our own hardware. Mainly, I mean, by now, since we are getting quite big, like we have a lot of customers that we provide our Anycast services for. So one of the points we have to choose from are like hosters that can basically offer us any bigger servers, like with a lot of RAM. That's like the main issue mostly. And also what's really important to us is the upstreams, because in order to optimize our Anycast performance, we have like selected a couple of tier ones that each of our clouds is like getting the best performance with, and we are looking for locations that are having those upstreams specifically to improve our performance. And to measure this, we usually mostly use the DNS perf or perfops statistics monitoring service, which you can find online with the DNS perf at least. And we try to get better at that. So looking for new locations is trying to see in which areas of the world we are still having a really bad round trip time, and to improve this. Yeah.
Before we go on, I have a question about that. You say you're looking for areas where you have, I guess, higher latency, right? That's what you're trying. Is that, how do you do that with modeling? Like we expect if we put something there, we'll get a better performance, or how do you do that if you want to talk about it?
So mostly we will check like which hosters are there, or any, like sometimes it's even customers who have offered us to provide co-location, so we can send hardware there. Most of the times we will check which kind of upstreams are there beforehand and if this could improve the performance. And most of the time it's just trial and error, basically, like especially if it's with a cloud hoster, we will just buy a VM, set it up. It's really automated, so we'll have it set up in half a day or something, and then see how it performs.
So at the RIPE MCC, we don't really use Docker or any other containerization technology for the name servers. We have physical servers, mostly Dell servers, and we have our own equipment at some of the internet exchange points like Links and AM6. So we have physical servers there, and then we have routing equipment, which is a mix of Juniper and Arista. And then, as many of you might know, we partner with our community, and they provide servers to us for the K-root and authoritative DNS service. And this is a mixture of either physical servers or virtual servers. And we then install our operating system and software on this to run them. And the routing there is done in software using Bird or FRR. And yeah, this model works well for us. We don't think we are going to do containerization or Docker or anything like that in the near future.
Okay, thanks. I think there were many other topics already mentioned briefly. So now the question is, what would you like to hear next? What topic would you like to hear the panelists talk about their experience?
Hi, Kurt Kaiser. What about the logs? Do you keep them, analyze them? What do you do with them?
Maybe let's start with Anand.
Yeah, so we have various kinds of logs on the servers. So we have the name server logs. We have bind and not DNS and NSD. And they all have their own log formats. What we do is we collect some metrics from the logs. And as a root server operator, we need to report some of these metrics to the community and to ICANN. These are known as the RSAC 002 statistics. So we have scripts to analyze them. And we also collect some of the other system logs to see what might be happening. And besides logs, we also do TCP dump. So we get PCAP data from the servers in case there are problems that we need to figure out. So yeah, that's what we collect.
Are any of you having a different approach?
So we do actually. So I think probably, I don't know, was your question mostly about query logs? Is that, oh, oh, well, in terms of just normal logging, we pull all our logs from our edge to the center, so we can use Grafana and things like that. We use Prometheus to get server stats, all this kind of stuff. But I thought the question was about query logs, right? And we actually don't provide full query logging because it turns out that with DNS, it's a super efficient, lightweight protocol. So logging a query is as expensive or more than actually answering the query, right? So we used to have a CTO, and his philosophy was, rather than spending terabytes every day gathering a bunch of data, which is mostly redundant and mostly going to be ignored, his idea was that you should build tools to extract the signal out from the edge. And he did a few presentations at ORC, and I think you're right as well about it. And he built an open source tool called Orb, and it basically works like this. So we will get counts of top N names, as well as things like TCP versus UDP and all the response codes and things like that, without actually doing the query logging. And that's worked really well for us in terms of both understanding what our load looks like. Like we can see if all of a sudden we're getting a lot of NX domains at a specific site, something's gone wrong, and we can investigate this kind of thing, which is normal operations. And it's worked pretty well over the years until very recently, but it turns out that customers want what they want. And I actually don't think it's crazy for a customer of an authoritative DNS server to say, I want to see the queries that you're getting. I actually find the business model that we have, I don't understand why people pay us for it. Not because we give a bad service, but because we say, we charge you per query. And then we say, okay, and this is how many queries we answered. Trust us. But they do trust us. And usually if we were fraudulent, it would be possible for them to tell, of course, because DNS is a service discovery, right? So if all of a sudden we said that you've gotten 10 times as many queries, but nothing has shown up at their web page, they'd be like, this is weird. So anyway, but the point is that some customers have asked for full query logging, and we're embarking on that. And there's a ton of different tools for that. And I don't actually know, we haven't actually finished our design for that, of where we're going to end up. So anyway, that's my long story about query logging.
Any quick thoughts on that?
Yeah, so in terms of query logging and statistics, so for our customers, basically, and also for internal insights, of course, but we use DSC. So we collect all the data, and we can also provide them to our customers, like at least on a TLD basis, not completely like for our secondary service, but yeah, this has been very helpful. And also for the TLDs, we offer our Anycast services for, we also have, we take some TCP dump samples, like in case they want to look in what kind of packages are coming in. And if they want to use this data, we will set up an account for them to download those PCAP files to analyze them.
Sorry, Jeff, but Andrei had a request first, so we'll give him the floor first.
My question would be, and sorry, Shane, because you are a developer as well, so it's more a question for the operators. So what would be like 3 or 5 like things that you find valuable in the DNS servers you run? I mean, like performance, features, transparency in the development, frequency of the releases, stuff like this. And is there anything that you are like really missing? And I don't mean this like implementation specific, like in general.
I see a lot of question marks.
I was just going to say no, actually, because I am in the fortunate position that I believe that I have very good relations with several of the open software producers for DNS software. So I feel very involved in the evolution of DNS software, and I feel listened to if I would have comments or need help. So that actually does work out quite well for me. And I think the question should be more directed to our customers, what now new types of DNS features they would like to see us provide, and then we would have to rely on software that other producers, in our case, for actually providing that. And that's a kind of a triangle dialogue. But I think it's ongoing and that it works well, at least from my standpoint. So I'm a happy camper.
Any other comments, thoughts on that?
What he said.
Awesome.
Yeah, well, I'd just like to add that, yeah, I think the DNS community is a very friendly and nice bunch of people. And at the RIPE NCC, we operate multiple name servers, and we have contacts with all the developers and the organizations that develop them. We have good dialogue with all of them, good contact. And yeah, one of the things we need when running a diverse family of name servers is, some kind of feature parity, because, we want all the name servers to behave in a similar way and not necessarily the same way. And yeah, when we bring up these discussions, they are often handled with speed and with a lot of friendliness. So yeah, I think it's great that we have this great DNS community.
It's great to hear. Jeff
Houston, APNIC. Let me disagree and point out, at least in the area of commercial DNS service for authoritative name servers, it often feels to me like the blind leading the blind, or the willfully ignorant leading the blind. How many name servers is enough? How do I compare two offerings? One says, I have 6 name servers. The other one says, I have 2. And some idiot says, I'm really better. I have 352 name servers. What's right? Should I have lots of IP addresses behind one name? Should I have lots of names? At what point do some recursive resolvers just give up and others doggedly query on for geological era, searching for an answer? What is actually healthy for this ecosystem? And to be perfectly frank, we've written nothing down. And so the consumer who's looking for someone to host their name has absolutely no guidance to compare who's offering what and what's better. Even if you take the top level zone, the root zone, and say, I'm going to take these 3,500 names and look at the number of name servers. There are 2 idiots with 13, .arpa and .dot. And then there's a bunch at, I think it was 6 and a bunch at 4. I don't know what's wrong with 5 name servers, but 5's an evil number. And you kind of go, why? Is this just finger in the air? It's what everyone else does. How much thought have we got into in terms of resilience? And what does resilience mean when it's not a standalone factor? It depends on the behavior of the recursive resolvers. It's great having 15 or 13 name servers, but if recursive resolvers only ever ask 7, are we wasting our time? And so if you try to sort of study what makes quality in authoritative name servers, I don't think we've ever studied it. We just, proudly proclaim we know the right answer when the answers are different all over the room. And B, it's kind of, doesn't this depend on the client software and its behavior as well? And maybe we should be looking at that. At the moment, you guys are building without really understanding what your recursive resolver customers are really doing. You really don't know. And the recursive resolvers, God knows what they do. Someone in this room might. But I tell you what, when you look at the various flavors out there, they all have different persistency timers and so on that actually determine how long they will follow a query before they just give up. And none of them, as far as I can see, apart from one, get to 13. Only one gets to that far. They just all give up early. So my point is that name server names, how many names is real and where should it go to? Number of name servers, and equally importantly, the number of IP addresses. And there's one there somewhere. Is there timing? In theory, recursive resolvers latch to the fastest answering authoritative name server, yes? And some vendors claim they're really good at this. Others say, nah, it's all about equal. When you start testing it, you get some remarkably curious behavior, and there's no solid evidence that a recursive resolver, given a choice, will latch to the closest. There's one in France that always likes going to a recursive resolver in America. It's kind of, why? There's one right beside you in the same city. No, we prefer the American answer. So in some ways, that kind of question is related to how recursive resolvers behave. And I suspect we haven't really done our homework here, apart from saying, you need to do 2 or more. I agree, but that or more thing is kind of weird. I don't think we understand it.
Thank you. No, we definitely don't understand it. I think that's why running these services is kind of witchcraft.
So in our case, we've got a ton of addresses that we advertise on, not for any individual customer, but we have pools. And early on, when we were still a startup, network engineers had ideas to provide resilience between individual customers by having mapping of addresses or some nonsense like that. I don't exactly know what they were thinking. But in reality, our operation now, we run an Anycast cloud, and we basically run 2 addresses. Of course, there's lots of addresses, but half are run on one half and the other half are on the other. So our network basically works on 2 addresses. But because we have a team of people trying to keep things working all the time, we're very reliable, and this actually works pretty well for us. Now, you're correct in that we haven't done the research, and I'm actually starting that now in terms of like comparing how our Anycast would be against, say, if Anycast was perfect, right? So I've done some initial measurements to discover that you guys in Australia, for whatever reason, your routing is perfect because you're so far from anywhere. If there's a mistake, someone will immediately complain, right? Places, our POPs in Europe, because we have a number of POPs in Europe, are a bit sloppier, but it doesn't matter because if it's adding 10 extra milliseconds, no one's going to notice because it's recursive. The places that there are still some places where things do matter, like in South Africa, occasionally traffic will get backcode to Europe, which is bad. And I haven't looked at Brazil, but I think it's a similar problem there where traffic would go to Miami and things like that. So you're right in that we need to look at this more. But I also think the reality is that DNS is a bit like TCP, which I know you've done research in as well. Like it will power through all kinds of badness. And because most queries end up at resolvers, yeah, it's mostly okay in the end.
The customer wants value for their money. They want quality out of what you guys are offering. And we're not even giving them any clues as between whether your service is better than yours or not.
You know, if I had a nickel for every time a customer has wanted to know the details about resolver behavior, I would have 0 nickel. I promise you, no customer has ever asked for this, ever. Maybe they should, but they don't know enough to ask for it. It's kind of our job to sort that out.
So Warren, Kumari, Google. This is probably foreshadowing, but fairly much every question that Jeff asked seems like something where there should be an answer in like a best common practices document, right? Like a lot of this feels like customers don't know what to ask because they're not DNS experts and shouldn't have to be. And going along like 4,000 name server names, probably a bad idea. 1, probably a bad idea. You want some number between 2 and 3, or 2 and 5 or something, but it should be written down. We've got lots of RFCs which tell you how to implement the protocol, but very little document on how to actually run stuff.
Just Willem, something there? Willem, just something online, or no? Okay.
So,
oh, sorry. One more question.
No, I just want to go back to that. There are multiple ways to do it, and you have defining good is also a problem in this big equation. You can do a lot of research, and that is a lot of research that needs to be done, but the results, I believe, are not going to be very conclusive. It will give you what I would like to see in a BCP. It will give you a number of trade-offs. If you go in this direction, you will have these benefits and these drawbacks, and if you go in this direction, there will be other benefits and other drawbacks, and that's what I would like to explain if there is work on such a document in the future. Then again, as you often say, there are things that are definitely bad that we can definitely recommend to not do, and on the other side, things that are definitely good and that we can recommend doing. But there's also a big gray zone in the middle.
So Tobias Siewich, Max Planck Institute for Informatics, and also one of the two editors of 3901 BIS, currently adopted by DNSOP. And over the past roughly year, we had several discussions in DNSOP concerning what to do with 3901, especially given that we have so many other things we need to select now. I mean, there's like DNS over TCP, DNS over UDP, DNS over QUIC, DNS over HTTP, DNS over TLS. What? Bingo. Shit, I forgot my bingo cards. Anyway, then we also have like IP address protocols, two of them. There's like a lot of things that should be documented somewhere, and if we start documenting it somewhere, it might get a very big document, and very big documents might get very good at not getting consensus, because somebody finds some little screw in the bike shed they kind of dislike. So an idea I posited there was to basically get that BCP and do like very small atomic things. Like, we don't really have happy eyeballs, but all of a sudden the transport people get ideas about happy eyeballs behavior in DNS. So maybe we should take all of these things and put them into that BCP to, well, at least not get told by transport people what the DNS should do.
Sorry, I'm talking a lot tonight. I can't have it. Just to be clear, not all documents are IETF documents, so not everything has to achieve consensus. So the previous work that was mentioned, the resolver recommendations, not best practices, recommendations, we did get a ton of feedback and there was lots of discussion, but we did not go out for a consensus call. There wasn't this IETF process that was followed. So if there's a concern that in a large-ish document, there's always going to be someone who complains about something, that's a valid concern, but there are ways to address that by choosing a place to publish it and a way to publish it that basically says, we're not even going to achieve consensus on this document. We're just going to make something that we claim, and it's opinionated, and that's okay. So.
I see that we are already transitioning into the second part of this panel session. So I would preferably like to take one more step back and maybe focus a bit on the technology first before we go into the broader discussion on the BCP in general. So if anyone of you on the mic have more a technical question, then go ahead first. Otherwise, I will come back to you, Phil. Yeah. Nope. Okay. Oh yeah, there is one. Okay, go ahead.
Technical question here. Babak with Quad 9. So there has been a lot of focus on encryption in the past few years on the user to resolver, basically DNS last mile. And we are, as a resolver operator, we're seeing a reasonable increase over time. So everyone is using encryption, but there has been almost no movement on the authoritative side. We've done some measurement. We have enabled opportunistic DOT, and we've seen some results, but most of the authoritative operators do not support it. I just wanted to know, what is your take on that? Do you think it makes sense to do, maybe in the long term? Do you have it on the roadmap at some point?
So I would say that yes, it's definitely on the roadmap. Maybe not with a definite timestamp on it, but it's at least in our mind in the future to do things along that path. We do provide different kinds of services, and I would argue that as a root server operator, we will not be the pilot implementers of that, because the root service is too important for the infrastructure. So we try to be rather late to the game with new features when it comes to the root service. But we do provide other services, and I can envisage that, here and now, without making any promises, that we could deploy this on separate machines in our virtual systems, where select customers who want to try out these new features could ask to be put. That could be one way of bringing it forward. But I think we have a bit of a chicken and egg problem here, because as a supplier, you don't want to do a lot of extra work if your customers don't demand it, and the customers don't really know to demand it, and they don't think that the supplier can support it. So there's a chicken and egg problem that we eventually, some point in the future, it will probably start to spin in a good circle, and it will get deployed. At least I hope so.
So we are actually currently designing this right now. We have an internal project where we need a decryption session between a recursive resolver that we're running internally and our authoritative servers. And so I'm gently encouraging the team working on that to make sure that we consider how we're going to turn that into a public service. We've done some initial looking at packets on our edge, for example, and we do see a lot of this opportunistic probing that you mentioned. Not a lot, maybe like 50 queries a second or something like that. But it's enough that we know that there are servers out there doing this. And we know that it's not just random probing, because we don't see that on other ports. We really see it on port 853. So we have a reasonable confidence that people really are trying to do a DNS over TLS. So my expectation is that sometime within the year, we're going to reach out to Quad 9, maybe Google, people like that, and say, if you want to do a sandbox experiment, enable this for specific sites, we'll try it out. And then probably we'll flip the switch and make it publicly available. I know some other big authoritative offers. I think GoDaddy maybe had this at one point. So yeah, that's our position. And I realize, but we also have to realize that because it's opportunistic, it is kind of a fig leaf, but it's better than nothing. So yeah.
Okay, considering the time, maybe one more question about technical implementations. Okay, I'm sure. Okay, Neil.
Okay, I'm wondering, in each of your operations, how much breadth there is of software diversity, and how significant this is in terms of quality of service.
So at the RIPE MCC, we run our services with a lot of diversity, and this is by design. Some of you who've been in the community long enough might remember that the NSD name server software was developed specifically to counter the monoculture, because at the time, all root name servers run bind. And we've taken this idea further over the years. So we now run 3 different name servers. We run Bird and FRR for routing, and then we have Juniper and Arista doing routing as well with actual routers. We don't yet have diversity at the OS level, but it is on our plan to look at this year. We currently just run Linux, but for some locations, we should not be using Linux. And so we're also looking at things like OpenBSD, for example. So we're trying to add diversity. This is a challenging thing to do, though, because you need to manage your configurations in the same way. Sometimes different implementations behave a little bit differently, and so you have to tune them and make sure that they are aligned. That does have a cost, but we believe that it is worth the cost of having the diversity. because we have been able to weather some types of bugs, due to this diversity. We've had, packets of death that will kill one name server, but the others survive, or something that disrupts one routing instance and the others survive. So we very much value this diversity. Yeah.
Doris, yes.
Yes, so it's similar for us. We do use multiple name services, and also additionally to that, we make sure that we do not upgrade them at the same time. So with every update, of course, there is also a chance that something will break. Yeah. And the same goes for OS upgrades and everything. So with our Anycast cloud, we just basically make sure that we have multiple options of software as well as that is possible. Yeah.
Right. Do the people still remember the comments that they had? And I will probably move on to the next part.
Did Andrei, you have another technical question?
Mike.
Does it work?
Yes.
Yeah. So I just wanted to ask if Hell Freeze is over and DELEC is finished, the DELEC working group is finished next month, and then the implementation did the work and is done in the next month. How quickly can you deploy that?
That's not the right question. The right question is how quick do we want to deploy that? We can get software in place fairly quickly, and as I mentioned before, we have good relations with the software providers, so we can get access to new software quickly. But we do want to test it, and we do want to roll it out in a staged fashion unless there is an absolute critical bug. The packet of death mentioned that would probably trigger a quicker rollout or an expedited process of testing and whatnot. But it could be deployed in our case. You're talking about the DELEC record, which is a totally new thing. So it would. The DNS world won't really know the impact of that new processing until we start to see it in production, and you will also have to have it deployed in the zone files that are part of the service that we provide. But I guess that in our case it could be at least a few months. We could make it happen if we see the need for that, but we also have to be very cautious with stability of the systems and stability of the DNS, the ecosystem as a whole. So it is a trade-off, and I would, in a case like that, I would look to a lot of collaboration between various providers, various customers, various operational fora like the DNSOArch and the RAP community here. And there's so many people that can work together to make this happen. But I guess that's there is a limited number of big DNS providers, and I guess there would be collaboration to make such a thing happen in a stable fashion. But yeah,
I was afraid you would say years, so months is I'm okay with months.
So from an alternate point of view, basically the limitation here would be me trying to convince our product people to let me implement it, or let one of our team implement it. And it would really only take, weeks or months tops. And we would not be so cautious. We wouldn't need to coordinate with everything, because our basic philosophy is we let our customers decide what level of risk they're willing to take, and they manage their own data. So if we don't provide the service, and they can't experiment with it at all. But if they want it, well, if any customer asks for it, then it'll be a super high priority. I don't think that's likely to happen. So we'll probably have it available for them when they start to ask for it. And I'm hoping, a few weeks or months.
Okay. All right. So we touched only on a few topics that we had on the previous slide, but there was a lot of interest on discussing, I guess, the next topic. So Phil, would you?
I don't want to answer the first question.
No.
Do you want to present that before?
No, you don't have to. I think we just take the discussion from where we left it.
Right. So anyway, I'm Phil Regnault. I'm president at DNS.org, small organization that has a few members involved with the operation and development of DNS on the internet, I would say. And I don't want to speak on behalf of my members because obviously I'm an administrator, don't have an operator hat. I'll give a disclaimer. I'm responsible for the kindness initiative at ICANN, which so many people love. And I wanted to just at least mention that there are several members here at DNS.org who are interested in putting together some kind of BCP initiative, getting together and putting our heads together, and we don't have to reinvent the wheel. So I think initially what we're thinking about is having a discussion around what's available of existing best practices, doing maybe some kind of analysis on what's missing. And that got me interested, of course, in what RIPE was doing besides, the other initiatives out there. And one thing I wanted to comment on is that BCPs don't necessarily have to create consensus. There just has to be a catalog of things that people generally agree on are good for someone at some level. Not everybody is going to implement everything. It's going to depend on their where they are in the food chain, basically in the tree, and then of course what kind of operations they're doing. And then of course there's trade-offs and the discussion about diversity, for example, has a cost and complexity, operational agility, ability to switch software, could just be as important because then you don't have to maintain multiple software teams. But anyway, what I want to get at is this is going on now within the org space. We've got a Mattermost channel. We're having this discussion. I think I can point to Warren and say, he's also interested in spending time on this, helping write some documents, or at least point to what's already out there. So if you're interested in this, also with maybe doing some collaboration with the RIPE folks, could we get together, put our heads, in a common space and try and figure out what should we be writing, what should we be cataloging, and produce something for the community. Thank you.
Someone like to directly respond to that? Otherwise, I'll move to the mic on my right.
Hi, Greg Choules, ISC. So yes, answering that first point, we need a best common practice document written by somebody, whether it's OAuth or RIPE or whatever, but there needs to be some lines in the sand drawn, as in, here's some good things to do, kind of responding to Jeff's point, really. Directly on the numbers of servers, 3. So people may well argue that 2 is, too many. 1 is absolutely too few. 2 is not really enough. 1,742 is way too many. But it's not just from the point of view of resolvers, having to do lots of hard work. It's also from the point of view of zone transfer. When you have a setup, it's not just primary, secondary that people have. Sometimes they do, but sometimes also people have multi-level zone transfer things where they've got, some kind of hidden database and there's a network of primaries and they're distributing to a network of secondaries. And the whole effort of doing that can be really huge if you've got a huge fan out. So, somebody should say, well, just guys, limit things a bit here, and then actually the whole system might, work a little bit better. So.
Okay, thank you. Then continue.
So I wanted to follow up on the BCP at IDF point. So having it in multiple smaller documents is, in my opinion, not only a matter of easier consensus, but also about maintainability, because some things change over time, and if you don't have to touch the whole document, that's usually easier. So if you can just plug out the one thing, like address families, or, well, maybe we just say, well, TCP is a goner now, flag day, everything quick. So that makes it easier to just keep it up to date. Because I've seen in the routing area that documents can stay around for a little longer, and when they stay too long, they don't really get better, like wine or cheese. They get diverging from current best practices.
Am I next? So Phil called me out. At the DNS.org meeting a couple of months, something ago, there was some discussion on sort of a panel fairly similar on writing some beacon. And I kind of poo-pooed the idea and said that I thought it was probably a bad idea because we'd never get around to it, blah, blah. And then I felt bad after that. So myself and Puneet Sood, who I think many people know, sat down and started sort of writing a document Basically, we started with a Google Doc and we just put a bunch of ideas in it. We tried to use the idea that this is supposed to be best current practices. And that means something where you can point at existing advice in an RFC as a good sort of starting point. We specifically did not want to turn this into, should you give all of your customers TSIG keys so that they can update their reverse DNS? Might be a great idea, might not. We thought this wasn't the right place to discuss it. But while writing that, we realized there's a lot of different advice that you have. And some of it is for authoritative, some of it is for recursive, some of it is for zone owners, some is for DNSSEC people. And so we started just putting a bunch of words together. And we figured we would like people to help contribute. We thought maybe organize a call every week or two where people show up, we all sit together on a call and actually type words. Because if you have a set time and people show up and you have sort of some sense of community, people put words down. Put a bunch of words down, and once we've done that, break it up into different types of document. One set of advice would be for authoritative, one would be for zone owners, etc. To Lars's point, yes, there's not a best practice for everything. I agree that 3 is the right number of name servers, unless you're running a different type of zone, in which case it might be 2 or it might be 14. But depending on what type of person you are and what type of org you are, you have different needs. So as I say, we started putting some words down. We were originally thinking DNSOArch, because that's where we knew that there might be some discussion. But I don't think it matters where. Like maybe it's RIPE, maybe it's OArch, maybe it's a combination of 2. I think the important thing is people just put words down, and then we can figure out how you break it up and how you publish it. I don't think, often people, when they see BCP, they assume IETF document. I at one point had said, let's do it somewhere and publish it through the IETF stream, but I don't think that matters. I think it should actually be some other document published somewhere. Don't care where.
So since you have already started doing something like this, can we understand this as you volunteering?
Yeah. I mean, I think ideally there'd be a couple of people who help organize some meetings and then try and just keep some excitement going so people show up and write words. We had started doing it in Google Docs just because it's easy to put stuff in things. We specifically did not want to have too much structure. A wiki is hard for many people to edit at the same time, but we could spend an infinite amount of bike shedding time on which format should we use, which version of GitHub, Markdown, Cramdown, who knows, but Sean. Wow, did I call you Sean?
Oh, yeah, so just I have no strong opinions. I really don't care, but there are some advantages of RIPE as a place to publish documents because RIPE, there is an organization, the RIPE NCC will edit it and publish it, and they maintain a repository for it. So if we choose to go with OArch, we'll have to invent that. And if we choose to go with the IETF, then there's this whole separate process, which is, as you know, I think for this sort of thing, possibly a little too elaborate, but that's it.
Matthijs Mekking, IC. Let me first start with what the right number of NS is, with 3 here. But from the back of here, I heard a different number and I sort of agree. Obviously, the right number is 42. But let me get serious right now. Talking about documents that are already out there, I'm reminded of a work I did 10 years ago, which is a DNS audit framework that we created, where at the time every TLD was sort of going through an ISO process and tick off the boxes, and we started a document which is more like what you need to consider, not necessarily what is the right number. And I think a document, if it's going to be written, should take that focus. And you are better off ticking off a box, I got 3 or 42 or whatever the correct number is, but you are better off explaining why you have that number. And the other question I actually have, which I'm missing from the slide, is what is the target audience? Is it the root? Is it the TLD? Is it the hosting company? Is it my pet project? Is it all of them?
Yeah, so I guess for the roots, we only would have an audience of 12 people, organizations, so that's probably a bit too limited. But that's definitely something we have to think about.
Actually, for the roots, that there is ongoing work within the Root Service System Advisory Committee in ICANN, which is producing service expectations for root servers, which you can translate into this.
Yeah. Okay, maybe I should have mentioned the root. In the
I don't know. I know you did it in jest, and that's fine. But I would, continue. I support you. I share lots of your thoughts, and I can toss in another document which was created by the .se, the Internet Foundation, the .se registry, actually in cooperation with us at NetNode, which is also touches on these things. So there are a lot of things we can put in the pile as starting points, so we don't have to write the document from scratch.
Also, one more quick comment, because I think like every zone owner basically has another issues and another, I don't know, they need different things in terms of resiliency and stuff like that. So it's going to be something that's valid for everyone, or you're just saying like, which kind of options do you have as an authoritative name server? Like, what things do you have to figure out how to do, and what are some ways that you could do this?
So I actually think that's a very important question, which I don't feel like we have a good answer to, is who this document is for. So when we were working on the resolver recommendations, we had the expectations that we wanted to encourage more organizations to run their own DNS resolvers and say, please don't use Quad 9, sorry. Please don't use Google, sorry. But run your own stuff, right? And so that was kind of that was our motivation. And so we had two different target audiences. One, well, several. We had the audience of people we would say, if you want to run a public resolver, one that anyone on the internet can query, here's a bunch of recommendations for you. And then slightly separate ones if you want to run a resolver for, say, your organization that's not open to the internet, university or business or whatever. And then also a tertiary audience of, say, you don't want to run these, but you want to have a good way to evaluate the organization that's going to run it on your behalf. So you can say, is this doing the privacy things that I want? Is it running with the modern encryption protocols and things like that? So those were the target audiences that we had. And for me, it's not at all clear what the expectation, like why. I've heard many people say we need such a document. Well, we don't need these documents. Of course, we would look at them and we would do everything we could to make them good and improve our operations based on them. But we already run high quality services. So are we intending to encourage a lot of third-party people to run their own authority servers? I don't think that's the intent here. So I think until we answer this question a lot more directly, I don't think we should spend too much effort going forward. So.
Can we keep it very short, because there's still people on the mic? Short comment? Yeah.
Just to echo what Shane said, I think the audience here probably does not need this kind of advice. But speaking from the point of view of the RIPE NCC, we offer delegation service. Our users create domain objects in the RIPE database to request delegation. And we often have questions from people saying, well, why do I need to use X number of name servers? Or why can't my name server be a recursive one as well? And I think that's the target audience. Because a lot of these people struggle with DNS. It's not easy for them. And I think that would be something we should aim for, that audience.
Quick comment, Ulrich?
Yeah. Hi, this is Ulrich from ICANN. Obviously, ICANN already has a document for best current practices, kindness. I think you all heard about it. Be happy to work on anything together with you, obviously. But I too wanted to say that I think the target audience is a key factor here that we're talking about, and we all agree that we don't need it, but there's a lot of people out there that don't have DNS as their main job, and we all would probably really struggle in other IT fields, And so would be very happy to have some best practices there, and we can help other people within doing their work when we give them best practices. And I think that is the key factor here, identifying who we're talking to. You know, small hosting companies and a small ISP somewhere, you know, it's like they have other problems, and we can make their life easier by saying, yeah, if you do this, you're relatively good.
So, Andrei here. I have somewhat strong opinion to not bringing this to IETF, not because I'm the DNS co-chair now and it would create work for me, but because the IETF is not the target audience. And we need the operators to like participate in this and then, you know, use this document, and IETF is a whole bunch of different people, and it's not the right place.
So on the whole audience thing, I think Matthias listed a couple of audiences, like 5 or 6 or 7 different ones. And Shane also, when he started talking about the recursive one, it's like the audiences, oh, the 2 audiences are, oh, the 3. I think what would be useful is if we just try and capture as much tribal knowledge as we have about DNS, and then it's not the audience. I think this is multiple documents for multiple different audiences. And I think many are sort of beginner folk of like, this is how you should think about things. So I think let's get some data down. And then, yeah, I also agree with Andrei. This is not an IETF document.
Yeah, one final comment.
Lutz Remarque. From the practical point of view, running a name server, I would suggest that the topic of this paper or recommendation should be named, it's always the DNS. And it should contain some recommendations how to deal with the situation which was not expected. Setting up a name server is not complicated. Setting it up in the correct way, whatever correct means, is not a problem. Running a server in an open environment is a problem. Over the last few days, I had a lot of problems with not responding of my authoritative name servers anymore, simply because somebody also in this meeting here does not finish their TCP sessions. They open up a new one, and the new one asks a question and leave it open. There is no sensible limit for such activity. And if you leave for this audience of normal operators the abuse or misuse or strange behavior outside, they will give up. Simply because it's not running anymore after 2 weeks, and they are blamed for, you did it wrong. They didn't wrong. They had some unexpected environment, and they have to deal with, and they need they have to find out what's going wrong, how to deal with such operation. This is allowed to bring a server out of scope, out of work for half an hour in order to bring everything back again. That's the question which arose in the practice.
Thank you. We ran out of time, and some people probably would like to catch a bus. Sorry, Andrei. Thank you for the panelists for volunteering. Thank you for the participation. I think there's more work to be done. I think there is an interest for a document in a way or another, so that's great to hear. Probably we will have to discuss this offline or on the mailing list. And with that, yeah, thank you and have a good evening.
Thank you for organizing this. I appreciate it.